Guys, I hope you guys are doing well. So for those that don't know me, my name is Dan or Daniel, and this is Maths with Dan. And this is my YouTube channel where we go through walkthroughs for A-level papers, GCSE papers, predicted papers as well, live streams, and so on and so forth. So yeah, welcome to my walkthrough for the A-level Maths Edexcel paper 2, June 2024. So I think it was an okay paper. I think it was easier than paper 1 for sure. There were a couple of tricky questions though, so definitely the circle question at the end, question 14, and obviously the last part of question 15 as well was tricky too. But overall, I think it was an okay paper. You have the timestamps in the description, and yeah, that's pretty much it. I will say again though, I've been saying this for the last couple of videos. I'm on about 9.1K subs and I'm trying to get to 10K by the end of the year. So if you do find this video helpful and you're watching it and you're not subbed, then just hit that subscribe button and yeah, hopefully we can do that together. That would be amazing, but it's a bit of a stretch because it's about November now, but we'll see how it goes. But anyways, yeah, that's pretty much it. I won't bore you anymore. Let's just get into the walkthrough. Okay, so question 1 says y is equal to 4x cubed minus 7x squared plus 5x minus 10. Part A says find in simplest form dy dx. So this is just standard differentiation, isn't it? So we've got y. I'm going to say dy over dx very, very simply. The power rule, bring the power to the front, take 1 away from the power. So 3 goes to 4 would be 12. So 12x to the power of 2 minus, and then 2 goes rid of 7, so 14, and then x, and then the 5x will just go to 5, and then the constant minus 10 disappears. So that's part A. Double I says find the second derivative, so we just need to differentiate again. So same thing, d squared y over dx squared. That is going to equal, bring the 2 of the 12, that's going to be 24, and it's going to be x, and then minus 14x goes to minus 14. The constant 5 disappears. So that's the second part. Now part B. It says, hence find the exact value of x when the second derivative is 0. So we know that the second derivative is 24x minus 14, so it's just setting that equal to 0 and then solving. So that is going to be 24x is equal to 14, which means that x is equal to 14 over 24, which we can divide top and bottom by 2, which is just 7 over 2. So therefore, x is just equal to 7 over 2. And that is question 1 finished. Okay, so question 2. Jamie takes an interest-free loan on £8,100. Jamie makes a payment every month to pay back the loan. Jamie repays £400 in month 1, £390 in month 2, £380 in month 3, and so on, so that the amounts repaid each month form an arithmetic sequence. Part A says show that Jamie repays £290 in month 12. Okay, so we know that we've got an arithmetic sequence, right? So essentially, let's write it as a series. We have Jamie's first payment, £400, and then the next one is going to be £390, next one's going to be £380, 370, and then so on and so forth, isn't it? Right? The payments are going down by £10 each month. So this is the first, this is the second, this is the third, this is the fourth, and we want the payment in month 12. So we want the 12th term of this arithmetic series, don't we? Right? Or sequence, right? We've got a series because we're adding them, right? So what do we do? Nth term formula, isn't it? So remember, un is equal to a plus n minus 1d, where a is the first term and d is the common difference. So in our case, we're going to have a is equal to 400, the first term. The common difference is 10, minus 10, because it's going down by 10, so minus 10. And then we want the 12th term. So we're just going to literally plug this into this formula. So it's going to be u12 is going to equal a, which is 400, plus n minus 1, which is going to be 12 minus 1, and then minus 10, isn't it? Like that. So now plugging all of that in, or we've plugged it in, let's simplify. So 400, and then that's going to be 11 times by minus 10, which is equal to 400 minus 110, which is indeed 290. So we've done it. That is part A. Part B says, after Jamie's nth payment, the loan is completely paid back. Show that n squared minus 81n plus 1620 is equal to 0. So remember, Jamie is making these payments. So pays 400, then 390, then 380, then 370. And after a certain amount of payments, the loan is completely paid back. So what that means is that this series, this sum at the end of it, right, it should all equate to £8,100, isn't it? So let me put that there, and then let's do that. So let's put that there. And then what we're saying here is that all of these payments will have to total 8,100, right? So what do we do? We're summing the terms in a series. So we're going to do the sum to n terms formula, aren't we? So remember the sum to n terms formula is Sn is equal to n over 2, 2a plus n minus 1 d. So we're just plugging in everything. So in our case, n is going to equal capital N, the value that we're looking for. And then a is 400. D is minus 10. And we know what the sum should be. The sum is 8,100, isn't it? So if I plug that all in there, then it's going to be, I'll do capital N, so n over 2, and then 2 lots of A, which is 400, plus n, which is capital N this time, minus 1, and then D is minus 10, like that. Close bracket, and then this should equal 8,100, isn't it? So what should we do first? Let's tidy up the bracket first. So I'm going to have n over 2, and then I'm going to have 800, and then I'm going to expand that minus 10, with the n is going to be minus 10n, and then minus 1 times minus 10 is plus 10, like that, and then that equals 8,100. And then what am I going to do? Let me just simplify the bracket a bit more. So n over 2, like that. 800 plus 10 is 810, minus 10n, and that will equal 8,100. Times by 2 is going to be n, and then it's going to be 810 minus 10n, and that is going to equal 16,200, isn't it? So now expand that. That's going to be 810n minus 10n squared is equal to 16200. What form do we want? And we want n squared minus 81, and always have the thing you're trying to show at hand. So we want n squared. So what I'm going to do firstly is I'm going to move everything from left to right. So it's going to be 0 is equal to, I'll put the n squared term first, and then minus 810n, and then plus, let me just make sure, yeah, that's fine, 16200. And then now we can just divide through by 10, can't we? So dividing everything by 10 is going to give me n squared, like that. That would be minus 81n, and then plus 1620, and then this will equal 0. And let's just compare what they wanted. N squared minus 81n plus 1620 equals 0 as required. So that's it. Perfect. That is part B. Now part C, what does part C say? It says hence find the value of n. Okay, so this one is not too bad. So let me just put that yeah, this is just solving this, isn't it? So we can just get our calculator now and put that in and see what we get. So so we want the value of n. So we're gonna solve this quadratic, aren't we? So where's my calculator? Over there. So I've got my solver up already. Gonna be 1 is equal to, and then minus 81 for that, and then 1620 for that, and that gives me 45 and 36. Okay, so then that means then essentially that quadratic actually factorizes to become equals 0. Let's check again. It's 36 and 45, isn't it? Yeah. So it actually factorize to be n minus 36, n minus 45 is equal to 0. So we've got two answers. N equals 36, n equals 45. But remember, we are repaying a loan, right? So we are going to choose the smaller value for n, right? Because that is, by the time we'll get to n equals 45, the payments will be negative, isn't it, right? So you're always, with these types of questions, you're always more often than not going to pick the smaller value, okay? So the n45, n equals 45 just comes from the algebra itself. In terms of the actual context of this question, it's going to take 36 months to pay off this debt, isn't it, right? So we're going to pick n equals 36. N equals 36. We're going to reject n equals 45. Yeah, and then you could always just to be safe, plug in 45 into your arithmetic or your nth term formula, and then you'll probably get a negative number out. So you know that it doesn't work in this context. But yeah, just to be clear to the examiner, just put n equals 36. And yeah, that's it. That's question 2 finished. Okay, so question 3 says the point 3 minus 2, or the point P 3 minus 2 lies on the curve of equation y equals f of x, where x is an element of the rows. Find the coordinates of the point to which P is mapped when the curve of equation y equals f of x is transformed to the curve of equation, and we've got these here. So the first one is y equals f of x minus 2. So guys, this is just literally graph transformations, right? All you need to know, or what you need to do with these questions, is just know your graph transformations very, very well. You're not giving them in the exam, so you have to make sure you know every single one of them. As soon as you know those, they're really easy. These questions are typically at the beginning of the paper, so there's no reason why you shouldn't be getting full marks on these when they come up. So let's do the first one, part I. So the way I like to do it is like this. Well, I've got f of x, right? And I know I'm dealing with this point 3 minus 2, right? I just put it equal to 3 minus 2. And then I ask myself, okay, well, I want f of x minus 2. So the question is, what does the x minus 2 do to our point? Well, if you look inside here, right, what you should know is that it's a horizontal translation. You always do the opposite of this thing. So because it's minus 2, it means that you add 2 to every single x coordinate only. So it only affects the x coordinate because it's inside, right? So it's going to be 3 plus 2 minus 2, which is just 5 minus 2. And that is your answer for part I, right? And then now you can just continue. So next one is double I. Again, the same thing. F of x is equal to 3 minus 2. Next one is f of 2x, right? Again, what does this do to your point? It's happening inside the graph, inside the bracket, sorry. So you always do the opposite. Because it's multiplying by 2 here, it means that you're going to divide your x coordinate by 2. It only affects the x coordinate. You do the opposite. So what that means is that it's going to be 3 divided by 2 minus 2, like that. And then that is equal to 1.5. So it's going to be 1.5 minus 2. Or if you want to leave it as a fraction, you can as well. 3 over 2 minus 2. Whatever one is absolutely fine. Again, so just remember your graph transformations, and that's it. Now, the next one, double I, is a bit trickier because there's a couple things going on here. But again, as long as you know your graph transformations, then you should be fine, okay? So we've got f of x. Again, we start from the beginning. The point P is 3 minus 2. And then now you want to do it step by step. Treat it like solving an equation, right? You'd always want to isolate this. So you do the inside and then the outside here, and then this is going to be the last thing you're going to do, right? So just treat it like that. So it's going to be f of minus x. That's going to be the next one. What do I do? Again, what's happening here? This is just a reflection in the y-axis. So because it's a minus 1 with times and by, it's just going to be times in the x coordinate by minus 1. So what you're going to do is you're going to say that the first one times that by minus 1. That's going to be minus 3 minus 2. That is your first step, and then you just want to build it up. The next part is the 3, right? We want to do the 3 first, right? So it's going to be, or the 3 next, I should say. So it's going to be 3 f of minus x, like that. Now, what does that 3 do? 3 do. The 3 is on the outside of the function. It's not happening inside the bracket. It's happening on the outside, so it affects the y coordinate. And all you do is you multiply that number on the outside by every y coordinate. So since it's a 3 on the outside, we have to now multiply our y coordinate by 3, like that. So it's going to be minus 3 and then minus 6. And this is where we're at so far. Then the last part is the plus 5. Again, that plus 5 is happening on the outside of the function. It's not happening inside, so it affects the y coordinate. What does the plus 5 do? It's just a vertical translation up by 5 units, which means that you add 5 to your y coordinate. So 3 f of minus x plus 5, right? This will translate to minus 3, and then you would add 5 onto that. So it's going to be minus 6, add 5, like that, which is equal to minus 3 minus 1. So this is our answer for triple I. And these are our 3 answers. So the first one is 5 minus 2. Second one is 3 over 2 minus 2. And the last one is minus 3 minus 1. And yeah, that's it. Finished. Okay, so question 4 says a sequence u1, u2, u3 is defined by un plus 1 is equal to kun minus 5 and u1 is equal to 6, where k is a positive constant. Given that u3 is equal to minus 1, part A says show that 6k squared minus 5k minus 4 is equal to 0. So this is recursive relationships. This is a typical question that's come up quite a bit where they give you the relationship, they give you a couple of bits of information, given that u3 is equal to minus 1, and they ask you to show some sort of quadratic, okay? all you're doing is just using this relationship here. Remember, we've got un plus 1 is equal to kun. If you look at this part here, n plus 1 and n, what is the relationship? To get one term, n plus 1, you need the term before it, un. So from there, what I can do is say that, well, u2, right, is going to equal k, and then the term before it, u1 minus 5. And then I can use that to figure out an expression for u2 in terms of k. And then once I've got that, I can use that to form an equation for the information given to us for u3, right? So let's go ahead and get started. So part A, we know that u1 is equal to 6. We've seen that u2 is going to equal k u1 minus 5. So we can plug in that. So that's going to give me u2 is going to be k lots of 6 minus 5. And then from there, that tells me that u2 is equal to 6k minus 5. And then remember, we want this quadratic here. They've given us that u3 is minus 1, so we can use that. Remember, u3, the same way u2 was equal to ku1 minus 5, u3 is going to equal ku2 minus 5. And we have an expression for u2 now, so we can just plug that in. And we also know what u3 is as well, actually. So we can say that u3, which you know is minus 1 from the question, is going to equal k lots of u2, which we figured out to be 6k minus 5, and we're taking away 5. And then now it's just a matter of expanding that. So minus 1 is going to equal, that's going to be 6k squared minus 5k minus 5. And then if I move everything over, that's going to be 0. It's going to equal 6k squared minus 5k minus 5 plus 1. And then that will give us, if I move the 0 to the other side, it's going to be 6k squared minus 5k minus 5 plus 1 is a minus 4 is equal to 0 as required. So that is part A done. Nice, easy 2 marks. Part B says, hence find the value of k. Now remember, with these types of questions, you've got to be very, very careful. We've got a quadratic here, so most likely there's going to be 2 solutions. Now, is there a bit of information about k? Yes, there is. K is a positive constant, so k is greater than 0. So what you could be doing as a rule of thumb here is just, if you ever see that type of statement, just make a note of it even before you start the question, just so you don't forget. So what that means is when I solve this quadratic, I'm going to look for the positive solution, right? More often than not, with these, you're probably gonna have a positive and a negative, so you just reject the negative. But let's see how we get on. So I'm factorizing this. What is this? Part B, right? And how are we gonna factorize this? We're gonna shout out Jack again. I'm gonna tell him every time I shout him out because this factorization method is so cool. Let me know if you do it this way in the comments, right? So 6k squared minus 5k minus 4 is equal to 0. You're gonna do 6 times minus 4, which is going to be minus 24. You want 2 factors of minus 24, which are going to add to make this middle number of minus 5. And that's going to be minus 8 and a positive 3. So therefore, all you do, guys, you know this 6k squared, drop the power. So it's going to be 6k. You're going to put another 6k here, like that, is equal to 0. And then you just put these 2 numbers in. Minus 8 plus 3. And then now you're going to see if any of these can be factorized, and they both can. So if I factorize this one out, I could take out a 2. It's going to be 3k minus 4. And then this one, I could take out a 3. And that's going to be let me just make sure I've done that correctly. That's fine. Taking out a 3 from that is going to be a 2k. Wait, hold on. Yeah, 2k plus 1. Right? 6k. That's fine. Yeah, that's fine. Just making sure I've done this correctly. Yeah, that's good. So now we can cross that out, and we can cross that out. So that means that we're going to have 3k minus 4 and then 2k plus 1. Like that is equal to 0. And once you cross these ones that can be factored out, this is your factorization. It works every single time, right? Again, shout out Jack. So now, setting these equal to 0. If I set that equal to 0, that means that 3k is going to equal 4. And it means that k is going to equal 4/3. That's one answer. And then this one's going to be 2k plus 1 is going to equal 0. That means that 2k is going to equal minus 1. K is going to equal minus a half. So we've got 2 values for k. We know that k has to be positive, so we reject this one. Let me just put a cross there. And this is going to be the one we're choosing. Like that, and I'll just do it here. So we're going to say k is going to equal 4/3 since k is greater than 0. So that is a part B I. Now we know what k is, we could do double I. It says find the value of, remember this is sigma notation, the sum from r equals 1 to 3 of ur, right? So I'll do that here. So double I is asking us to find the sum of r equals 1 of ur to 3. And all that means is that you're going to plug in u1, u2, and u3. You just need to sum what these are, and that is your answer. Now, they told us U1 was definitely 6. I remember that. U2, we had an expression for it in terms of K, which was 6K minus 5. And they told us U3 as well. U3 was minus 1, right? So let me just make sure I've written that correctly. U1 was 6, U2 was 6K minus 5, and U3 was minus 1. Perfect. But remember now, we know what the value of K is. K is 4/3. So we can plug that in. So I'm going to say K is equal to 4 over 3. And that would mean I'm going to have 6 plus 6 lots of 4/3 minus 5 minus 1. So that's just a matter of working it out. That's 6. 6 divided by 3 is 2. 2 fours are 8. So that's 8 there. Minus 5 minus 1. 6 plus 8 is 14. Minus 5 minus 1 is minus 6. So it's 14 minus 6, which is 8. So therefore, we can say that the sum of r equals 1 to 3 of UR is equal to 8. And that is it. That is question 4 finished. Okay, so question 5 says, given that theta is small and in radians, use the small angle approximations to find an approximate numerical value of theta tan 2 theta over 1 minus cos 3 theta for 3 marks. Okay, so again, this is just very, very straightforward. They're given to you in the formula, but I'll write them anyway. For sine theta, when theta is small, it's approximately theta. For tan theta, when it's approximately small, it's equal to theta as well. And for cos theta, when it's small, it's approximately 1 minus theta squared divided by 2. So in our case, what do we have? We've got tan and cosine. So let's do those. For that one, it's going to be tan 2 theta. And remember, it's the angle that you're looking at. So it's going to be approximately 2 theta, isn't it? And then for cos of 3 theta, again, you're just looking at the angle. It's going to be 1 minus, and the angle is 3 theta, so it'll be 3 theta all squared divided by 2. Like that. Let me just make that a bit nicer to look at on the eyes. The theta's not really looking good, is it? So I'll do it again, like that. Perfect. And then now, remember that theta, it doesn't have any trigonometric expressions over it. So we can just leave it as theta. So all we're going to do is just literally plug those in and then see what we get. So I'll do it here. It's going to be theta multiplied by tan 2 theta when it's small. So 2 theta. So I'll put that there. All over 1 minus, and then in a bracket, because we're doing a subtraction here, 1 minus 3 theta all squared divided by 2. And now it's just a matter of algebra and tidying this up. So numerator is going to be 2 theta all squared, like that. And then this is going to be, if I expand that minus, it's going to be 1 minus 1. And then the minus makes a positive. It's going to be plus 3 theta all squared divided by 2. So tidying up a bit more, it's going to be 2 theta squared on the top. 1 take away 1 is 0. 3 theta all squared is 9 theta squared. We're dividing this by 2. So now tidying that up, I'll do it right here. That we're dividing by a fraction, so we can flip it in times. It's going to be 2 theta squared multiplied by 2 divided by 9 theta squared. I forgot the squared here, like that. And then now, it's just a matter of cancelling out, isn't it? That cancels with that. The theta squares cancels. You've got 2 times 2 over 9. That's 4/9. And that is literally it. That's it for 3 marks. That must be the easiest question in the entire of these 2 pure papers. I think the first principle one in paper 1 was easy, but I think this has to be the easiest question. Like I'm on what's the word? I'm on flight mode when I'm doing this walkthrough. But yeah, that's it. That's question 5 done. So question 6 says, figure 1 shows a sketch of the curves with equation y equals f of x and y equals g of x, where f of x is equal to e to the 4x squared minus 1, where x is greater than 0, and g of x is equal to 8 ln x, where x is greater than 0. Part A says find f dash of x and double I g dash of x for 2 marks. So I've just got that summarized down here. So to differentiate these, so we got a couple. We're differentiating exponential e and then logarithm natural log ln, right? So a couple of things. Whenever you're differentiating e to the function of x, right, then this is always equal to, I'm going to write y dash for dy dx, right? Just can't be asked to write it. Is always equal to, you differentiate the function in the power, so f dash of x, and then you multiply by e to the f of x. So that is it for that one. And then for ln x, if y is equal to ln x, then this will always differentiate to become 1 over x. So these are just some standard derivatives that you should know. So with the first one, I'll write here I. We know that f of x is equal to e to the 4x squared take 1. So that would mean that f dash of x, right, would equal, we differentiate the power, 4x squared minus 1 differentiates to just 8x, isn't it, right? Because the 4x squared differentiates to 8x, the minus 1 goes. So it's just going to be 8x at the front, and then we're going to multiply by e to the function, which is 4x squared minus 1. So that is part I. Double I, we're differentiating 8 ln x. So g of x is equal to 8 ln x. So differentiating that g dash, that will equal, 8 is a constant, so we're going to times by the 8. And then ln x, we know differentiates to 1 over x. So it's 8 times 1 over x, which is just 8 over x, isn't it? So these are our two answers for part A. So part A is done. Part B, I've actually got summarized down here. I just put it a bit low just in case I need a bit more room, but I didn't need that much. So it says for part B, given that f dash of x is equal to g of x, given that f dash of x is equal to g dash of x at x equals alpha, show that alpha satisfies the equation 4x squared plus 2ln x minus 1 is equal to 0 for 2 marks. So we've got a value, x equals alpha, which is at the point of intersection of these two graphs. So all you got to do is just equate them, isn't it? So f dash of x, we know, is going to be right here, part B. F dash of x is 8x e to the 4x squared minus 1. And we're going to equate this to g dash, which is 8 over x. And apparently we need to use algebra to show that we get that equation there. Now, for me, when I look at this, right, to show that question, for me, the fact that I've got an ln in the show that, right, and there is no ln's in the original equation that I've written down, this one here, it tells me that I need to get rid of this e, isn't it? The only way we can get ln's anywhere is if we get rid of an e, right? Because when you take the ln of something, it cancels the e. So with that being said, what that tells me, in terms of like a thought process or a way to start, is I would want to isolate this e, right? And I'm going to do that by dividing both sides by 8x. So if I divide both sides by 8x, right, then obviously on that side, that would just be e to the 4x squared minus 1. And then if I do it on that side, dividing by 8x is the same as multiplying by 1 over 8x, isn't it? So I'm going to write like that. And it's just easier to look at. So right hand side, that cancels with that. 1 over x times x is 1 over x squared. So I've got 1 over x squared on this side, and I've got e to the 4x squared minus 1 on that side. Now, remember, the show that has ln's in it, I want an ln. So I'm going to take the ln of both sides now, right? Which is the whole point of us getting rid of the 8x. So taking the ln of both sides, like, right? That will cancel with that, wouldn't it, right? So it would just be 4x squared minus 1 is equal to the ln of 1 over x squared, like that, okay? Now, always have what you're trying to show at hand just so you can see where you are, where you need to get to. We need an ln x, right? We've got ln of 1 over x squared. But remember your log laws, right? We've got a fraction inside here. Remember, ln of a over b is equal to ln a minus ln b. So I can actually split that, can't I? So I can say that this is just equal to, on this side, the ln of 1 minus the ln of x squared. And then this one's going to be 4x squared minus 1 on that side. Now, you can use your calculator, but this is a standard one. You should know that the ln of 1 is always 0. So, well, not always, it is 0. So, you can cross that out. And that means I'm just left with 4x squared minus 1 is equal to minus ln of x squared. And then from here, remember, log laws. We know that the ln of a to the power of n is always equal to n ln a, right? That power can drop to the front. So therefore, this just becomes 4x squared minus 1 is equal to minus 2 ln x. And then from here, remember to show that we want 4x squared plus 2 ln x minus 1. So all we need to do now is move that over to the left. So therefore, we're going to have, I'll do it here, 4x squared plus 2 ln x minus 1 is equal to 0 as required. And that is it for part B. Perfect. We've done that. Now let's get to part C, which I've got summarized here. So the iterative formula, xn plus 1 is equal to square root of 1 minus 2 ln xn over 4 is used with x1 equal to 0.6 to find an approximation value for alpha. Okay. Part C says giving each or calculate given each answer to 4 decimal places the value of x2. So this is just iteration, isn't it? You're just plugging this into your calculator. So all I'm gonna do is I'm gonna get my calculator up here. So put this here. We want x1 to be 0.6. So I'm gonna store 0.6 like that, and then I'm going to literally put that formula in. So it's gonna be square root first, which is gonna be there, fraction 1 minus 2. And then the ln, where's ln there? And then I'm going to put answer, aren't I? Because I've stored that, which is going to be there. So 1 minus 2 and then answer over 4. And remember, 0.6 is x1. So if I want x2, I'm just going to click it once, aren't I? Yeah, so I get that there. So you know what? Just to obviously show some working, ci, to get x2, I'm going to say x2 is going to equal the square root of 1 minus 2 and then 0.6 of over 4. Like that, and then that is going to equal to 4 decimal places. That's 0.7109. 0.7109. Let me just double check that one more time. 7109. Perfect. Fantastic. And then now to find alpha, the actual root, right? All you do is just keep pressing equals, isn't it? Because it's going to converge eventually. So all I'm going to do now is I'm going to get my calculator again, and I'm just going to keep pressing execute. So keep clicking execute and see what it eventually converges to. So we can see it's 0.67, 0.67. Yeah, it's not happening anymore. So it's converged to 0.6706, isn't it? So I'm going to just say alpha is equal to 0. Let me just check that one more time. What was it? 6706. 6706. And that is it for question 6. Guys, this paper is so easy. You know, I'm doing this walkthrough and I'm thinking, oh my days. Guys, let me know. Is this paper? This paper is definitely easier than paper 1 for sure. I'm just thinking, oh my days. Sometimes I've got to do these questions again and make sure it makes sense and but I'm breezing through this paper. But yeah, let me know what you guys think of this paper. I think it's super easy. It's only question 6 anyway, but we'll see. Anyways, that's done. Finished. Okay, so question 7 says figure 2 shows a sketch of the straight line L. Line L passes through the points A and B. Relative to a fixed origin O, the point A has position vector 2i minus 3j plus 5k. The point B has position vector 5i plus 6j plus 8k. Part A says find A to B for 1 mark. So this is very, very straightforward. So I'll do it here. Part A. To get the vector A to B, you always just do B minus A, isn't it? I'll write like this. OB minus OA, but it's just B minus A. And what I like to do is I like to write it in columns. I think it's easier, but since it's in IJK notation, I'll write it back in IJK notation. So the vector OB, right, is that one, 5, 6, 8, minus the vector OA, which is just that one, which is going to be 2 minus 3 and then 5, like that. And then that's going to equal 5 take away 2 is 7. 5 take away 2 is 3. I added them, my bad. 6 minus 3 is a 9, right? So that's 9, like that. And then 8 minus 5 is 3, like that. So it's 393. But remember, because it's in IJK notation, you want to write it as your final answer. 3i plus 9j plus 3k. Yeah? So that is part A. That's done. Now, part B. It says, given that a point P lies on L such that the magnitude of A to P is equal to 2 lots of the magnitude B to P, find the possible position vectors of P for 4 marks. So there's a couple of ways you can do this. I think the most straightforward way is probably just looking at the problem, looking at the diagram. So let's actually get that because that's super important, right? So I'm going to get this here and I'm going to just put this here. I could have just written it, to be fair. I think that would have been faster. Needed a laptop. Anyways, yeah. So when I look at this, right, now that's in the ratio 2 to 1, because what I can do is I can just divide that. So I can say that the magnitude of A to P, like that, if I divide both sides by the magnitude of B to P, like that, then that's going to be equal to 2. And then I could put that over 1, which quite clearly just shows me it needs to be 2 to 1, right? So I need that relationship. I need 2 parts for A to P, and I need 1 part to be B to P. How can that happen? Where could P be for that to be true, right? Now, I think the most straightforward way is if B was to lie B, if the point P was to lie beyond B, right? then let's say it was here, and that would mean that this distance, A to B, would be the exact same as this distance, B to P. That would be satisfied, isn't it? Because if I do that, that would be A to P, like that. And then we can see that this distance, A to P, is just twice this distance, B to P, right? So that is definitely one way we could get a possible position for P. Now, how do we get that position? Well, there's a couple of ways to do it, right? So let me just move this here. Oops, no, I need the whole diagram, sorry. The whole diagram needs to go there. Oh, let me grab the whole diagram. Unless that goes, that's so annoying. This is so annoying. I need to have a chat with OneNote and put that back there. Okay, so how can that happen? Well, the only way that can happen is if we have we start at OA. We start at this point A. So I'm gonna say we're looking for the position vector of OP. So O to P, right? This will equal. We start at point A, which is gonna be O to A, right? And then we add on. You can do this two ways. You could either start at A and then add on two of these, right? Which is just the same as two of AB, because that's the same as that, isn't it? We worked out what AB is. So if I add two of AB like that, that will take me to P. Or you could either say that O to P would be equal to, if we start from point B, which is O to B, then we just need to add on one of them, don't we? So you could either put this in or put that in, doesn't matter. They will both give you the same result, and that will be one position for P. So let's do that one. We'll do this one at the bottom. So it's gonna be, I'll say O to P is gonna equal O to B. What was the position vector of B? It was 5, 6, 8. So 5, 6, 8. This is OB plus A to B, which is what we calculated there to be 393. So that will be 393, like that. And then that will equal 5 plus 3 is 8, 6 plus 9 is 15, and 8 plus 3 is 11. So that would be a possible position vector for P. So I'll write like this. O to P is going to equal 8i plus 15j plus 11k. And that is going to be one way that P can be on this line, right? That's one of the answers. We need the other position, which is a little less intuitive, but I've got the diagram here. So remember, we want to satisfy that relationship 2 to 1, right? We want two parts to be AP and we want one part to be BP. How can that be satisfied? Well, P could lie before B, couldn't it, right? If I was to put B, if I was to put P here, sorry, put P over there. Remember, we want it to be two parts. This has to be two parts. That has to be one part, right? That is satisfied. It doesn't matter that P lies before B now. It's still satisfied. That blue distance is twice the yellow distance, right? So how could we find out what that position is? Well, remember, if this is if this is two parts, we could say 2x there, and that's x there. Well, then from there, we could say that that distance in blue is going to be 2/3 of the way, and then this distance in yellow is going to be 1/3, right? Just the way you would do it in GCSE with vectors. So for me, when I look at this, how can I find that point P? Well, then that just tells me that I've got OP. Well, I'm going to start at A, which is going to be OA, and then I would have to add on 2/3 of the vector A to B, isn't it, right? A to B was, we figured out to be, what was it, 393? Yeah, 393, like that, right? So therefore, it's going to be A to B like that. And so the answer is going to be, well, O to A. What was O to A again? O to A was 2 minus 3, 5. 2 minus 3, 5. So that's going to be 2 minus 3, 5. And then we're going to add on 2/3 of the vector A to B, which was 393, isn't it? So 393. So doing that, that's going to be 2 minus 3, 5. Add 2/3 into all of that. 2 over 3, that's going to be 2. 2 over 3. Let me just do it here so I don't make a mistake. 2 over 3 times by 3 is going to be 2. 2 over 3 times by 9. 9 over 3 is 3. That's going to be 6. That's going to be 6 there. And then 2 over 3 times by 3 again is going to be 2. Now that isn't it. So it's going to be like that. And so therefore, we just add those together now. 2 plus 2 is 4. Minus 3 plus 6 is a 3. And then 5 plus 2 is 7. like that. And that will be the other position, right? Which is going to be 4i plus 3j plus 7k. So those are our two positions. Either it lies past B over there, point P lies past B, or it lies before B, right? So I'll just write the 2 points here. So OP equals either, what was the first one again on top here? AI plus 15j plus 11k. AI plus 15j plus 11k. Or it's this one, 4i plus 3j plus 7k. And those are our two answers. And that's it. That's question 7 finished. Okay, so question 8 says, prove that 1 over cosec theta minus 1 plus 1 over cosec theta plus 1 is equal to 2 tan theta sec theta, where theta is never equal to 90, a multiple of 90 degrees, right? So this is a 3-marker, it's a standard show that question. So I've just got it summarized here, so I don't need to keep going up and down. So remember, it's a show that you just need to have a good knowledge of your trigonometric identities, right? So we'll start with the left-hand side, right? But what I like to do when I'm doing show that is I just have a look at the right-hand side. So I need to get this result here. Now, from our identities, we know that tan is sine over cosine, like that. And we know that sec is 1 over cosine, right? So 2 tan sec, right, is the same as 2 times sine over cosine multiplied by 1 over cosine. So when I'm doing the left-hand side and I'm using algebra and so on and so forth, I want to make sure that I remember that I need to get this result here. If I can get this, then I know I'm done, right? So how do we start the left-hand side? Well, whenever you see these types of algebraic fractions, you always combine them more often than not, right? So what I'm going to do is I'm going to cross multiply. So cross multiply will mean I'll times that with that, and I'll times that with that one, and then I'll times the two denominators together. So that would mean it would become cosec theta plus 1, right? Because I would times that by the 1, right? And then plus, and then I would do cosec theta minus 1, and then I will times that by the 1, right? But since they're both 1, I don't need to write anything else. I can literally write like that. And then on the denominator, remember, we just times them together. So it's going to be cosec theta minus 1 multiplied by cosec theta plus 1, like that, right? So this is what we combine them. We can drop these brackets at the top here. So we can do that. And then what can we do from here? Well, firstly, should I do it here? I'll do it. I'll lower this a little bit and then I'll just do it next to it. So I'll lower that a tiny bit and then I'll do it next to it like that. So firstly, the numerator, right? We can cancel those ones. That cancels with that. So that's just going to be cosec plus cosec, which is 2 cosec theta, which is good because we know we need a 2 in the show that, right? Show that the thing we're trying to get is 2 tan sec, right? So now we've done that. The denominator, we've got cosec minus 1, cosec plus 1. You should recognize this to be just the difference of two squares, right? All right, a minus b, a plus b is just equal to a squared minus b squared, isn't it? So with that being said, I can say that this here is literally just equal to cosec theta squared, cosec squared theta, minus 1 squared, which is just 1, right? So I can just drop that power of 2 on the 1. So this is where I'm at. Now remember, it's to show that question. Always have what you're trying to show at hand, right? We need to get 2 tan sec. Let me just bring this down actually. Okay. So I'll just put this here just so we have it. And then move this here. Okay. So this is what we're trying to get to. This is where we are at currently. Now, remember, identities, identities, identities. Can you use any identities that we haven't used yet? Or look at the denominator. You should recognize this one. Remember your Pythagorean identities. We know that sine squared plus cos squared is equal to 1. How do I get cosec squared? Let's divide everything by sine squared. I like to write as just an abbreviation. If I divide by sine squared, that's going to be 1. That's going to be c squared over s squared. And that's going to be 1 over s squared. And remember, this is just 1. C over s, cos over sine is cot squared. So cot squared theta. And then this is cosec squared theta. Now, we have cosec squared theta minus 1. I can get that, right? If I take 1 away from both sides, that will just leave me with cot squared. So cot squared is equal to cosec squared theta take 1. And then that means I can replace cosec squared theta with just cot squared. So I'll do this over here. like that. So that way it will become 2 cosec theta over cot squared theta. Now remember what we're trying to get. We're trying to get 2 tan sec, okay, which we know is 2 times sine over cosine times 1 over cosine. So what I can do from here is now let's get those. We want tan, right? We want sec. Let's get sines over cosines. Remember, we know that cosec is 1 over sine. So that's going to be 2 times 1 over sine theta on the top. And on the denominator, cot squared, we know, is cos squared over sine squared. So now we got that. We can just say, well, then this is the numerator. We can bring this out. So it's 2 times 1 over sine theta. And then we're dividing by this fraction here. Dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to have sine squared over cos squared. Like that. And then, well, what can we do from here? Can anything simplify? Absolutely. I've got a sine here. I've got 2 sines on top here. One of them will cancel. And then that will cancel with that one there. So that is just going to be equal to 2 times 1 times by sine over cos squared. Like that. Now, remember what we're trying to get. We're trying to get 2 tan sec, right? Which we know is 2 times sine over cosine times 1 over cosine. So are we able to distribute these around so we get that? Absolutely. I'm going to do it on the next page here. So let me just tidy up. So that's 2. 2 times 1 is 2. I've got sine theta over cos theta times by 1 over cos theta. Isn't it? Right? Because remember, sine over cos times 1 over cos, that's going to be sine over cos squared. So these are the exact same, like that. And then from there, I can say then, well, I've got 2 times by sine over cos is tan. So that's going to be tan. And then we know that 1 over cos is sec, like that. So therefore, we have to finish off with 2 tan theta sec theta as required. And that is it. That is part A finished. Okay, so part B says, hence solve for x between 0 and 90 degrees, the equation 1 over cosec 2x minus 1 plus 1 over cosec 2x plus 1 is equal to cot 2x sec 2x. Give each answer in degrees to 1 decimal place for 4 marks. So typical part B of these types of questions. Part B, you have a show a trigonometric expression is equal to another one. And in part B, you use what you've done in part A to solve an equation, right? So what are we doing here? So what I've done is I've actually got part A for us underneath, and you're going to see why. Because if I look very closely, if I look at this part of part B, the left-hand side of the equation, right? It's very similar to the expression in part A. The only difference is the argument, right? The 2x has been, the theta, right, in part A has been replaced with a 2x, hasn't it? So what I'm going to do, I'm going to rub these out. I'm going to rub out these thetas here. Remember, this is the identity. I'm just going to remove the thetas, the arguments, right? And remember, I can put in anything here, right? As long as I'm consistent, right? This identity will hold. So I'm going to replace it with a 2x, aren't I? Because that's what I've got in my expression in my equation in part B. So put 2x there, put 2x there, and I put 2x there, right? So that tells me that this here, right? The left-hand side of the equation in part B can be written as that, isn't it? So what you want to write as your first line is 2 tan 2x sec 2x is going to be equal to cot 2x sec 2x. That would be your first line. I think you probably get 1 mark for that, or maybe not actually. Anyways, we need to solve this now. If you look at left and right hand side, you may be tempted to say, well, hold on, I've got a sec here and a sec here. I can cancel them out. But the moment you do that, you will lose a solution, and you never want to do that. So I'll give you an example. Let's say I had, for example, x squared is equal to x, right? What you could do, algebraically speaking, is you could divide both sides by x, and then you're going to get x is equal to 1. And you think, okay, well, I've solved it. However, there is a solution that you're missing, x equals 0. So what you'd want to do, instead of dividing, you'd want to move that to the same side. X squared minus x is equal to 0. Factorize x minus 1. And then you got your 2 solutions. You've got x equals 0, the one you missed. And then this one, setting that equal to 0, will give you x equals 1, right? So whenever you have this type of expression here, it comes up a lot on both sides. Never, ever, ever, ever divide. You should always move to one side and factor it out, okay? So With that being said, we're going to have 2 tan 2x sec 2x minus cot 2x sec 2x, like that, and that will equal 0. And then now we can factor out that sec 2x like that. So we'd have sec 2x bracket, and then it would be 2 tan 2x minus cot 2x, like that, is equal to 0. And then we're setting this equal to 0 or that equal to 0. So it's going to be from two parts. So we could say sec 2x is equal to 0. That's one solution. Or 2 tan 2x minus cot 2x is another solution. Now with this one, I just realized actually, this is 1 over cosine, right? That equals 0. That is never going to equal 0. That's a fraction, right? A fraction can't equal 0, right? So, I mean, unless the numerator is 0. But, I mean, if I have a constant at the top which isn't 0, then the bottom can't be 0. So this can never equal 0 here, which means technically you could have divided it here, but this is just a nice case of it. In general terms, always factor and take it out, right? It just so happens that this one doesn't equal 0, so it's fine. So what we're going to say here is that there's going to be no solutions here. So we know that the solutions are going to come from this equation here. So we need to solve 2 tan 2x minus cot 2x is equal to 0. How do we solve that? Well, you always want the same trigonometric expression. And we know quite clearly that cot is 1 over tan, isn't it? So I can replace that. I can say what 2 tan x minus 1 over tan 2x is equal to 0. And whenever I have this type of setup here, when I've got, for example, x minus 1 over x is equal to 0, always times everything by x to get rid of the fraction, right? And get a quadratic. So I'm going to times everything by tan 2x. Tan 2x. That will give me 2 tan squared 2x minus, it will just be 1 because it cancels, and then that will just be 0, which would mean that 2 tan squared 2x is equal to 1. That means that tan squared 2x is equal to 1/2. And then that means that tan 2x is going to be plus or minus the square root of 1 over 2, isn't it? Which I can write as 1 over root 2 or root 2 over 2, whatever you want to do. I'll just write 1 over root 2, which rationalizes to be root 2 there, which is going to be root 2 over 2. Yeah. So you know what? I'll use that. I'll just use that just because I did it. Why not? So let me put that there. So that should be half there, and then I'll move that. I'll just write it again here. So this is root 2 over 2. This is what we're solving. Root 2 over 2. Okay, so that means we've got two solutions here. So the first one is going to be when tan 2x, sorry, is equal to root 2 over 2, and tan 2x is equal to negative root 2 over 2. Now, before we do this though, remember the range was between 0 and 90, isn't it? Right? Now our arguments haven't got x, it's got 2x. So if the range is between 0 and 90, then because our argument is 2x, what I could do is solve it when it's 2x, and then I know how far or how low I need to get to. I just need to go to 180. Anything above 180 or less than 0, I know that I can immediately disregard, right? So let's solve this one. So we're going to do the tan inverse of root 2 over 2. So here's my calculator. Calculator's there. I'm going to do tan inverse. It's in degrees. That's good. Tan inverse of root 2. I need a fraction bar. I need a root 2. And I'm going to divide that by 2. And that will give me 35.264 blah, blah, blah. 35.2643 blah, blah, blah. Was that it? Yeah, that was it. Now, remember, because I know that 2x has to be between 0 and 80, and I know the period of tan is 180, the next solution would be when I add 180. But that would immediately take me out of this range. So I know that I don't need to even add it. And if I was to go backwards to get the solution before it, that will take me before 0, be less than 0. So I know that this is going to be the only solution here. 35.2643. But remember, we want x, not 2x. So now we just divide by 2. So dividing that by 2 is going to be, I'll just do answer divided by 2. Shift answer over 2. That's going to give me 17.632. which to one decimal place, which is what they wanted it to, is going to be 17.6 degrees. That is one answer. The next one is when I solve this one here, right? So doing the tan inverse of that, that's going to be 2x is equal to, and then putting that in there, it's going to be negative of that, isn't it? Minus 35, but I'll just do it anyway because I want the actual answer. So shift tan inverse of minus, and then fraction bar is there. I need a root 2 over 2. Like that. That gives me minus 35. So minus 35.264.3. Like that. Right? Hold on, that looks a bit messy. Let me just get rid of that. Write that again. Okay. So again, remember the range is between 0 and 180 for when the argument is 2x. So I know that this is not going to be a solution because that's less than 0. To get the one that I want, I need to add 180, don't I? Right? And that is going to be the only one, because if I add another 180, it will take me outside. If I was to minus it, it will take me still outside. So all I know is that the only answer is going to be when I add 180 onto that. So I'll put it into my calculator. I'll just do shift answer plus 180, and that will equal 144. 0.73 blah blah blah. So that means that I have 2x equal to 144.7, or is it 356 blah blah blah. But remember, we want x, don't we? So x is going to equal, we just divide that by 2. So half in that is going to be shift answer divided by 2. That gives me 72.4 to one decimal place, isn't it? So I'll just do it. Let me write this: 72.367, which is going to be 72.4. So therefore, your final answers are just going to be x equals 17.6 and x is 72.4 degrees. And that is it. That is question 8 finished. Okay, so question 9 says, the graph in figure 3 shows the path of a small ball. The ball travels in a vertical plane above horizontal ground. The ball is thrown from the point represented by A and caught at the point represented by B. The height, h meters, of the ball above the ground has been plotted against the horizontal distance, x meters, measured from the point where the ball was thrown. With respect to a fixed origin O, the point A has coordinates 0, 2, and the point B has coordinates 20, 0.8, as shown in figure 3. The ball reaches its maximum height when x equals 9. A quadratic function linking h with x is used to model the path of the ball. Part A says find h in terms of x, and this is a 4 marker. So there are pretty much 2 ways you can do this. I'll do it both ways, and then you guys can determine which way you guys prefer. So I've got it summarized, part A summarized here. So the first way is we're trying to find what h is in terms of x. H is a function. This is a curve, and it's quite clearly a quadratic curve, isn't it, right? We've got a turning point, we've got a couple of points. So what I'm going to do first is say, well, h of x then, whatever it is, we can write as the general expression for any quadratic, which is ax squared plus bx plus c. So now it's our job to figure out what A, B, and C are. Once we do that, then we've answered the question, right? We've figured out what h is in terms of x. Immediately, we can see that the intercept is 0, 2, right? So what I can do is plug in x equals 0, and then I'll get 2 out. Or you can just do it by inspection. The y-intercept is going to be 2. So immediately, you know that C has to be 2, right? So I'm just going to write here, since we have 0, 2. Let me write, we have 0, 2. This tells us that C must equal 2. Again, you can plug in x equals 0 into there, plug in y equals 2, you will get C equals 2, right? So therefore, I can update this and say that we've got h of x so far is equal to ax squared plus bx plus 2. Okay, now we need to figure out what A and B are. Now, what else have they given us? Remember, whenever you're trying to find a curve or an equation of any function, and you've got A, B's, and C's and D's, whatever, always use the points that are given to you, right? Remember, we've got the point 20, 0.8. That means when I plug in x equals 20, y equals 0.8, and we can use this to find an equation in terms of A and B, right? So let's use that here. So I'll do that. I'll do it here. So 20, 0.8. That would mean that h of x, which is the same as y, is going to be 0.8. It's going to equal a lots of 20 squared plus b lots of 20 plus 2. And then now we can tidy this up a bit and see what we get. So that's going to be 0.8 is equal to 400a plus 20b plus 2. And then I can say then if I move, I'm going to write it this way, right? 400a plus 20b, like that. And then if I bring that there, then that would be minus 1.2, isn't it? So it'll be minus 1.2. And then now we have an equation in terms of a and b, right? Now, we can't just use one equation to find a and b. We need another one. So it's simultaneous equations here. So we need another equation in terms of a and b that we can use to solve simultaneously. And let's have a look at the information, right? They told us the ball reaches its maximum height when x equals 9. Well, what does that mean? Remember, the maximum height is going to be here. So that's going to be x equals 9 over there. What do we know? Think of calculus. We know that the gradient is 0 here. So in other words, dh by dx is equal to 0, right? So the stationary point is when x is equal to 9. So what we can do to figure out another equation in terms of a and b is to differentiate to find dh by dx, or h dash of x in this case actually, and then plug in x equals 9 and say equal to 0. So I'll do that now. So I'm going to say then h of x was equal to ax squared plus bx plus 2, because we knew what c was. H dash or dh dx, whatever you want to do. Or no, you'll do h dash because it's function notation. Differentiate that. Remember, a is a constant. Bring the 2 to the front. It'll be 2ax. Drop the power by 1. Plus b is a constant as well. So bx will differentiate to just b, isn't it? So it'll be 2ax plus b. And we know that the turning point is when x is equal to 9, right? So because of that, we can say that 2a times 9 plus b must equal 0. Remember, this here is the stationary point. H dash of x is equal to 0, right? Or dh by dx. Same thing, yeah? So that goes there, and then obviously it happens when x is equal to 9. So that way we have another equation. We've got now 18a plus b is equal to 0. So now we can solve these two simultaneously. So I'll write it out here again. So we've got 400a plus 20b is equal to minus 1.2. And then we've got 18a plus b is equal to 0, right? So now I'm going to get my calculator. I've got my simultaneous equation up. So I'm going to just plug them in. It's going to be 400. It's going to be 20. It's going to be minus 1.2 over there. And then it's going to be 18. It's going to be 1. It's going to be 0, isn't it? Like that. And then I get A, which is the first one. A is going to equal minus 0.03. And B is going to equal the second one, which is 0.54, isn't it? 0.54. And we already know that C is equal to 2. So therefore, our final answer for h of x is equal to ax squared, so minus 0.03x squared, plus b, which is 0.54. So x and then plus 2. And that is your final answer. And that is one way of doing it. You'll never ever get it wrong this way, because you're just doing the algebra, you're finding the values. So this is one way of doing it. So I'll do the next way now in another video. Okay, so the second way you could do this question is, instead of using the general form of quadratic ax squared plus bx plus c, you can use the completed square version, right? You could try and express this in completed square form. And you are able to do that because they've told you that the maximum height is at x equals 9. So that's over there. And then if I just drop a line down like that, that's x equals 9. How can I express that algebraically? Remember graph transformations, right? If I want to have a turning point of a quadratic to be at x equals 9, then we're going to have a square bracket like that. We're going to have x here. Remember, we're moving it to the right. So we flip the sign. It's going to be a minus 9 here, like that. That is the first thing. Now with this, you got to be careful, right? All this tells me is that I have a quadratic with a turning point at x equals 9. That could mean it could either be like this. It could be at 9 like that, which is going to have a graph that's open downwards with a minimum point. Or it could look like this. Have 9 there, and it's open upwards like that, where we have a maximum point. How do we distinguish or determine which one we need? We need to put a constant in front. Remember, graph transformations, this is a number that will multiply your quadratic, and depending on the sign of it, right, will determine which way it goes, right, in terms of if it goes upwards or downwards. So that's why we need that there. Now we can see quite clearly that it's going downwards, so we know that a is going to be negative. So you can either do this two ways. You can either start off your expression as this, a, positive a, or not positive a, just a, x minus 9 all squared, or you could put a minus like that. It doesn't actually matter which one you use. The points given to you will determine what value would be. So for example, because we know the graph is going downwards, if I was to use this second option, then the value I would get would for A would be positive once I plug everything in. Or if I plug it into this one, the first one, then A is going to be negative. It doesn't matter. It just depends on how you define A. So that's the first thing, right? Secondly, when I look at this quadratic, right, the y-intercept is at 2, right? How is that possible? It would need to be shifted upwards or downwards for it to be able to have an intercept that's not 0, right? So let's just say I have this here. Technically, it would have to be up here, isn't it, right? But how is that possible? We would need to shift it up, right? Let's just say we have this here. We would need to shift it up by a certain value. Let's just call that b, which would mean that we need to write a b at the end. So what I'm going to just finish this off and I'm going to say that our general expression for h of x is going to be, I'm going to use the first one. So it's going to be a x minus 9 all squared and then plus some constant b, which will allow it to shift upwards so that we have the y-intercept to be at 2, right? And this is all you need to do really. And then once you've done that, you can just use the points to solve it simultaneously and figure out what A and B are. So let's go ahead and do that. We've got 0, 2, and 20.8. So the first one is 0, 2. So plugging that in, that's going to be y is 2. So it's going to be 2 is equal to A, and then x is 0. So that's just going to be minus 9 all squared plus B. And then that is going to be 2 is equal to, that's positive 81. So 81A plus B, which I'm going to write it like this here. So 81A plus B is equal to 2. That's one equation. And then the second equation is if I use 20, 0.8, isn't it? Yeah, perfect. So 20, 0.8, that will be 20. No, sorry, not 20, 0.8, because that's the 0.8 is the y. 0.8 is going to equal A lots of 20 minus 9 all squared plus B, like that. And then that is 0.8 is equal to 20 minus 9 is 11, 121. 121A plus B. And so therefore I can put that there. So I have 121A plus B is equal to 0.8, like that. And then now I can just solve these two simultaneously, can't I? So you could just put this into your calculator or you can just do it. To be fair, I think it's actually easy to do it here. So just take these away, take away, take away, take away. That is going to be, that's going to be minus 40, isn't it? It's going to be minus 40A. The B's will cancel and that will equal 2 takeaways of 8, which is 1.2, which means that A is going to equal 1.2 over 40, like that, which is going to equal 0.03. Forgot the minus there, by the way. But let me put this into the calculator. I need to go to menu and then calculations, which is 1. And then it's going to be, yeah, I've actually got it here actually. 1.2 over minus 40 is minus 0.03. So that's going to be minus 0.03 over there. That's fine. And then B, now we know what A is, we could just plug into find B. So I'll just plug it into this one here. It's going to be 81 lots of minus 0.03 plus B is equal to 2. So therefore, we're just going to do that and then take away. So as my calculator, I think I've done it here anyway. Yeah, so let me clear this, by the way. Just clear that like that. So it's going to be 81 times minus 0.03. That is equal to minus 2.43. So minus 2.43 plus B is equal to 2, which means that B is going to equal, add that on, it's just going to be 4.43. So we've got A and B. So therefore we can say h of x is equal to A, which is minus 0.03, and then x minus 9 all squared, plus B, which is 4.43. So that is it. Or you can write a bit neater, put the 4.3 first, minus, and then 0.03 x minus 9 all squared. So either one of these is fine. And that is the second way of doing it. So you guys in the comments, let me know which way you prefer. Okay, so part B says give one limitation of the model. So there are many things you can say here. Just think of anything that would put your model into a problem. So remember, we're modeling the path of the ball. Who says it's going to be quadratic? It may not be quadratic, right? Another thing is maybe the path, the horizontal path may not be horizontal, right? There could be lots of bumps. Maybe the shape of the ball would affect its motion. Remember, let's say you have, when we're playing football, you guys play football. Sometimes you get those balls that are oval shaped as opposed to just being round and cylindrical. I was about to say cylindrical, spherical, right? That could affect the motion. So there's many things you could say. They haven't mentioned anything about air resistance. The ball may not be modeled as a particle, it could have dimension and size, stuff like that. So just think of mechanics as well. Just anything that will tie into uh, a problem with the model. So I'll just keep it simple. So you can say any of what I've just said, but I'll just keep it simple and say for part B, you could just say air resistance may not be considered. May not be considered. But you can literally say anything like that. Okay, so that's done. Now part C, what does it say? It says Chandra is standing directly under the path of the ball at a point 60 meters horizontally from O. Chandra can catch the ball if the ball is less than 2.5 meters above the ground. Use the model to determine if Chandra can catch the ball. Okay, so we've got Chandra here. Let's draw her in. So we've got Chandra. So let's just say she looks like that. And then we've got her legs there, and then she's trying to catch the ball. So let's just put her arms above like that, right? She's trying to catch the ball. Let's just give her some nice big gloves like that. She's trying to catch this ball, right? We know that she stands horizontally 16 meters from O. So this here is 16, right? Which would mean that she's at a point of x equals 16 from O, right? She can catch this ball if the ball is less than 2.5 meters above the ground, right? We have a model for the height of this ball. So all we need to do is say, well, we want to figure out what this vertical distance is here. So from here all the way to her feet, we want to figure out what that distance is here. And all we need to do is just plug in x equals 16, right? And figure out what that y coordinate would be. If that y coordinate is less than 2.5, then she could catch it. If it's greater than, then she can't, right? Or if it's even equal to 2.5, she can't, because it says that she can catch it if it's less than. So if it's 2.5 or more, she can't catch it. If it's less than 2.5, then she can. So all you got to do is just plug in x equals 16 into your model. I've got both models here, so you can use either one of these, but I'll use the first one because I think it's a bit easier. So where's my calculator? Got it here. And then I'm just going to plug in x equals 16. So let me write here actually. I'll do 4.43 minus 0.03, 16 minus 9 all squared, right? Which is equal to 4.43 minus 0.03, and then 16 minus 9 is 7, isn't it? So 7 squared. So I'll put that into the calculator and see what we get. So 4.43 minus 0.03, and then 7, oops, I forgot the dot, and then 7 squared. That is equal to 2.96. So this distance 2.96 is obviously more than 2.5. So she can't catch the ball. So what you're going to say here is that this distance here, I'll just write like that. This distance here is 2.96 meters, right? So what we're going to say is 2.96 is more than 2.5. So Chandra can not catch the ball. She's not tall enough. She's not tall enough. And that is it. Finished. Okay, so question 10 says, Figure 4 shows a sketch of the curve C with parametric equations x equals t plus 3 all squared and y equals 1 minus t cubed for t between minus 2 and 1 inclusive. The point P with coordinates 4, 2 lies on C. Part A says, using parametric differentiation, show that the tangent to C at P has equation 3x plus 4y is equal to 20. And this is a 5 marker. So I've got this summarized here, just so we don't need to keep going up and down. So we want the tangent, equation of the tangent. So remember, the general formula is y minus y1 is equal to mx minus x1, right? Where x1 and y1 is your general point and m is your gradient, your tangent gradient anyway, yeah? Because we're dealing with a tangent. So what do I do? Well, firstly, we've got the 0.42. So we know that we can plot that in. So we've got 42 like that. So therefore, we could say that we've got y minus 2 is equal to m and then x minus 4. So what that means now is that I just have to figure out what the gradient is. And we do that by finding the derivative, right? We need to differentiate. Now we're differentiating parametrically, so we need to use the chain rule, isn't it? So remember the general formula for dy dx when you're dealing with parametric equations is you're gonna have dy over dt on the top, you're gonna have dx over dt on the bottom. And it's just literally as simple as that. So let's differentiate both of these and see what we get. So firstly, x, let me do it here. X is equal to t plus 3 all squared. We can either expand this or use the chain rule. Use the chain rule because you've learnt it. Dx dt, bring the power to the front, 2t plus 3 to the power of 1. You times by the inside derivative. That differentiates to 1. So this is just going to tidy up to be 2 bracket t plus 3 or 2t plus 6, whatever you prefer. So that's dx by dt. dy by dt now, what was y? Y was 1 minus t cubed. So I'll do it here. Y is equal to 1 minus t cubed. So dy over dt is literally just going to be 1 will disappear, it will just be minus 3t squared, isn't it? So now I've got that, I can say that dy dx then, or you know what I'll do, just so I'll put this here. Why not? So I can now say that dy dx then is going to be dy over dx is going to equal dy over dt, which is minus 3t squared, divided by 2t plus 6. Okay, so now we need to figure out what t is, isn't it? Now, how do we do that? We know that the point P has coordinates 4 and 2. Remember what 4 and 2 means just from a very basic perspective, right? This means that when x is equal to 4, y is equal to 2, right? We know what x and y is parametrically. So what we could do is put the parametric equations and equate them and see what the value of t must be for both of them, right? You could do it for one of them. I think you could do it for y and you'll get it. But just to be on the safe side, do it for both. So remember, we know that x is t plus 3 all squared. So I've got t plus 3 all squared is equal to 4. And I want to figure out what the value of t must be, right? So square root on both sides, I'm going to have t plus 3 is going to equal plus or minus the square root of 4 is 2, which means that t is going to either equal minus 3 plus or minus 2. So we're either going to have t is equal to minus 3 plus 2, or t is equal to minus 3 minus 2. So t is going to equal minus 3 plus 2 is minus 1, or t is going to equal minus 5, like that. So it's either one of these two, but remember, t was defined to be between minus 2 and 1, right? So it can't be that one, right? So it has to be t equals minus 1. I've got part B here. We'll do that later. So we know it's t equals minus 1, but just to be on the safe side, just plug it into the other one as well, just to be safe. So remember, y was 1 minus t cubed. So if I put it in, 1 minus t cubed is equal to 2. That means that 1 minus 2 is going to equal t cubed. So that means that minus 1 is equal to t cubed. If you cube root both sides, you're going to get minus 1 is equal to t. So we can see that we got the same value for t. T equals minus 1 in both sides. So we know it's definitely t equals minus 1. Now we know that, we can plug that into our dy dx. So I'm going to say then that dy over dx is going to equal minus 3, and then t is minus 1, so minus 1 all squared, over 2 lots of minus 1 plus 6. That's going to be minus 3 times a positive 1 over minus 2 plus 6, which is negative 3 over positive 4. So the gradient of the tangent is negative 3/4. And now we can plug this into our tangent formula. Remember, it's a show that we want to show that we get 3x plus 4y is equal to 20. So what I can do now, there's not a lot of room on this page, on this paper. Must be easy. So I'll just do it here. So we're going to have y minus 2 is equal to m, which is minus 3/4. And then x minus 4. And then we need to show that we get 3x plus 4y is equal to 20. So what could we do? What's the best thing? Should we expand? Let's expand because that cancels anyway. So we got y minus 2 is equal to minus 3 over 4x. That will be a plus. The 4s will cancel, be plus 3. And then now what I'm going to do is I'm going to move this there, and I'm going to move that there. So it's going to be y plus 3/4 x is equal to 3 plus 2 is 5 times 3 by 4 now. I'm going to have 4y plus 3x is equal to 20. And then we can just write the other way because they wanted it 3x plus 4y. Yeah, exactly. So let's just write it the other way. Just move this here. And then now we can say that it's going to be 3x plus 4y is equal to 20 as required. And that is part A finished. Let's go to part B now. Okay, so part B says the curve C is used to model the profile of a slide at a water park. Units are in meters, with y being the height of the slide above water level. Part B says find, according to the model, the greatest height of the slide above water level. Okay, so we know that y is defined as the height, right? So the greatest height is going to be dependent on what y is. So let's look at y. Let's investigate y, right? Now, y is a cubic function. We want the greatest height. If I look at the diagram, we can see that the greatest height occurs over there, right? And then it just goes down. But we could just investigate this more closely just by looking at what the height depends on, which is this function there. So let's sketch y equals 1 minus t cubed. So if I do this here, let's say if I was to sketch t cubed, for example, t cubed looks like that, right? Then minus t cubed from graph transformation is just a reflection of the x-axis. So it's going to look like this, right? This is minus t cubed. And then what does that 1 do? It's just a vertical shift up by 1 unit. So 1 minus t cubed is literally going to look like that, isn't it? Right? This is going to be y equals 1 minus t cubed, right? The intercept is going to be at 1, and the x-intercept is going to be at 1 as well, isn't it? From it, yeah, 1 as well. 1, 1. Okay. So, how do we answer the question? It's quite easy now, right? We can see that this graph here is decreasing for values of t, right? As t increases, y decreases. So what I can say from there, I'm going to say just from here, y is decreasing, right? Which means the greatest height, right? I'll put in brackets, or the max of y, right? Occurs when t is at its smallest. Definitely, right? You can see from the picture. T is defined between -2 and 1. The smallest value there is -2. So you could say, therefore, t is equal to -2. So all you need to do is just plug in -2 into y, and that will give you the answer. So y is going to equal 1 minus, and then -2 all cubed. That is 1 minus, that's a negative, so it's going to be another negative. 2 cubed is 8. So y minus 1 minus minus is 1 plus 8, which is equal to 9. So therefore your answer for the greatest height is going to be 9 meters. Make sure you put your units of measurement. And that is it for part B, and that is question 10 finished. Okay, so question 11 says, figure 5 shows a sketch of part of the curve of equation y equals ax squared minus ax squared e to the minus 3x, where x is greater than or equal to 0. The finite region R, shown shaded in figure 5, is bounded by the curve C, the line with equation x equals 1, the x-axis. Find the exact area of R, given your answer in the form a plus b e to the negative 3, where a and b are rational numbers to be found for 5 marks. Okay, so what do we have here? We're trying to find the region R, right? The region is bounded by the curve, a line with equation x equals 1, and the x-axis. How do we find regions bounded by curves? It's just definite integration. So we need to integrate this function here. And actually got the graph here underneath, actually. Just so we don't need to keep going up and down. So to get R, we need to integrate this region, right? Or integrate this curve, sorry, ax squared e to the negative 3x, right? And where are we integrating it between? X equals 0 and 1. Right, so this is going to be the region R. That's the first thing, being able to identify that it's an integration problem. Now that we've done that, we need to ask ourselves, well, what method of integration are we going to use? If I inspect the curve here, what I look at, or what I notice, is that I've got completely two separate functions, right? And what I think to myself is, well, how would I differentiate this? You would use the product rule, wouldn't you? Right? Because you've got two different functions here. Now, because we're integrating, you're going to use by parts, right? Because by parts is actually derived from the product rule. So let's just say, whenever you see an integration problem and it looks like a product rule problem, more often than not, it's going to be a by parts integral, right? Most of the time. Sometimes, if there's a relationship between the expression and the power, you can use the reverse chain and so on and so forth. But that's just the general idea. If something looks like a product rule problem, if you were to differentiate it, it's typically going to be by parts. So we're going to use by parts here. So let me write this down again. So we've got the integral of 0 to 1 of ax squared e to the minus 3x. Now, what is the by parts formula? Let's remind ourselves. It's the integral. If I've got integral of v du dx, why have I got a star there? Don't want that. V du dx. This is going to equal it's going to equal u v minus the integral of u dv. So when you're doing this, you need to ask yourself, okay, well, what is going to be my v? What's going to be my du, right? And the way to do that, I think there's a couple of rules out there. I think there's like an I-late rule or something like that I've seen online. But the way I like to do it is ask myself, well, what would I want to differentiate? What would make my life easier? And what would I want to integrate? Now, ax squared, if I differentiate this, the power drops by one, the power drops by one. So the degree drops, which makes it a simpler expression. So that tells me I'm going to use that to differentiate, right? So that means I'm going to make v equal to ax squared. So v is going to equal ax squared. And then du, right, is going to be e to the minus 3x. Right? Now, integrating or differentiating e pretty much is the same. Just the only difference is the actual constant itself. But it's pretty much the same. So it doesn't really matter which one that is. So since the other one would be easier if I was to differentiate it, it would make sense for this to be v and that to be du. So all we got to do now is just plug everything in. So let's figure out what dv by dx is. dv by dx, this is just standard differentiation. That's just going to be 16x. Integrating that, remember, how do we integrate this? We keep it the same, so e to the minus 3x, and then we're going to divide by the inside differential. So differentiating minus 3x would be minus 3. Dividing by minus 3 is the same as times by minus a third. So we get that there. So we've got everything we need now. Now we can plug this into the formula. So what I'm going to do is we've got uv, isn't it? So I'm going to write here just so it's super clear. We've got the integral of 0 to 1 of ax squared e to the minus 3x dx is going to equal uv, so these two. So doing that, that's going to be, I'll just do it like this. Will be minus a third e to the minus 3x times by ax squared minus the integral of u dv dx. So these two times together, isn't it? So it's going to be minus a third e to the minus 3x times by 16x dx, right? Now, what I'm going to do is I'm going to just drop the limits for now. I'm going to figure out what this whole integral is and then put the limits on after. So I'm going to just drop these for a second and let's just tidy this up. So this one is going to be, if I tidy it up, we'll put the constants together, it's going to be minus 8 over 3. I'll put the x squared first as well. And then I've got e to the minus 3x and then minus the integral of that over there, isn't it? So that's going to be minus a third times 16 is minus 16 over 3. And then I've got the x there, and then I've got e to the minus 3x dx, right? Now, I've got minus 16 thirds. This is a constant. We can always bring that constant on the outside, right? So what that means is that that will become minus a over 3 x squared e to the minus 3x, and then it'll be minus and then minus 16 over 3, and then the integral of x e to the minus 3x dx. Okay, so now that just becomes minus a over 3 x squared e to the minus 3x, two negatives make a positive, plus 16 over 3, and then the integral of x e to the minus 3x dx. So we're not done yet, are we? Because we've got another integral to do. So when I inspect this integral, again, I've got a product of two different functions here again. So we're gonna have to use by parts twice. So this is an integration by parts problem where you have to do it twice. So what I'm gonna do is I'm gonna isolate this. So x e to the minus 3x dx. I'm gonna use by parts on this and then do the exact same thing. And then once I've got it, I'll bring it back and put it in replace of that. So again, we're gonna make v equal x, right? And we're gonna make the u dx equal e to the minus 3x again, because when I differentiate x, it just reduces, doesn't it? So dv dx is going to equal 1. U, when I integrate that, it's going to be minus the third e to the minus 3x. And then now we plug in everything into the by parts formula. So I'll do it here equal to, remember, it's u and v. So these two times together, u and v. So that is just going to be, I'll do minus a third. And then the x will go here. And then that will be e to the minus 3x. And then minus the integral of u dv dx. So these two times together, isn't it? 1 times minus a third e to the minus 3x is just going to be the same thing. So it's going to be minus a third e to the minus 3x dx, like that. And then now we can work out what that is, isn't it? So that is just going to be, well, let's do it here. It's going to be minus a third x e to the minus 3x. And then that minus a third, just like we saw before, we can put this on the outside. It can join that minus, so it's going to be positive a third, right? So it's going to be plus a third. And I've got the integral of e to the minus 3x dx. And then now that is just going to be minus a third x e to the minus 3x plus 1/3, and then I'm going to integrate that there. That is just standard integration now. So that's just going to be minus a third again, and then e to the minus 3x. How many times have we integrated this today? But yeah, so we get that, and then now we can tidy this up a bit more. Let me just make sure that's all good. Yeah, that's good. So now we can tidy up a bit more, and it's going to be minus a third x e to the minus 3x. A third times minus a third is minus a ninth. Minus a ninth, and then e to the minus 3x. And that is the integral of x e to the minus 3x, isn't it? So this integral right here. We've worked out what that is. We can now plug that into the original integral that we were working out. So therefore, we can now say that the integral of, what was the original again? Ax squared. Ax squared e to the minus 3x dx, right? Without the limits, remember, we've still got the limits to do, is going to be this. I'll just copy this, why not, instead of writing it out again. This, oops, not going to let me copy it. Let me try one more time. If it doesn't, I'll just write it again. I want to copy that. Thank you very much. Copy that. And then that will go there. And then it will be this, isn't it? 16 over 3 of the blue integral, which is this one, isn't it? Right? So that would go inside there. So that would be minus a third. And then x e to the minus 3x minus a ninth e to the minus 3x. And then now we need to just tidy it up, and then we'll apply the limit. So let me just tidy that up over here. So this one is going to be, if I expand that, that's going to be minus 16 over 9 x e to the minus 3x. And then that one's going to be 16 over 3 times minus 1 over 9. It's going to be minus 16 over 27 e to the minus 3x. Like that. And then I have minus 8 over 3 x squared e to the minus 3x, like that. And now I've successfully integrated it, right? Now I'm going to put the limits in. Now that I've done it, let me just copy that. And I'll put this on the next page. Where's copy? There we go. I'll put this on the next page with everything. And then that should give me it. So put that there. So we're integrating that. And then we know that this is now equal to this thing over here. So copy, put that there. I think I need a new laptop. It's a bit slow. So yeah, like that. So now remember, the question asks us to integrate between 0 and 1. I just removed the limit so I could figure out what the actual integral is. Now that I've figured out what the actual integral is, I can put the limits on. So now all we're going to do is we're going to just literally just put 0, 1 there, and that would mean I could put a square bracket like that, and then we're going to evaluate those limits between 0 and 1. So now let's do the upper limit and see what we get. So upper limit is going to be minus 8 over 3. It's going to be 1 squared, e to the minus 3 lots of 1, minus 16 over 9, times 1, and then e to the minus 3 lots of 1, and then minus 16 over 27, and then e to the minus 3 lots of 1. That's the upper limit. And then, yeah, let me just work out upper limit first. So what is that? That's just going to be minus 8 over 3. 1 squared is 1, that's fine. That's going to be e to the minus 3, minus 16 over 9, e to the minus 3. And then e to the minus 3, and then minus 16 over 27, e to the minus 3. So when I look at these, remember, we want it in a certain form, by the way, as well. We want it in the form of a plus b e to the minus 3. A plus b e to the minus 3. I'll write that just over here, just so we have that right in red. A plus b e to the minus 3. That's the form that we want it in. So let's just make a note of that, okay? So now, with this one, these all have e to the minus 3s in them. So all I need to do to simplify that is just to work out what the coefficients are, right? Just put this literally into my calculator. Minus 8 thirds, minus 16 over 9, minus 16 over 27. Put it into my calculator and see what I get. So my calculator is over there. So it's going to literally be minus 8 over 3, minus 16 over 9, and then minus 16 over 27. And that will equal minus 136 over 27. So minus 136 over 27, e to the minus 3. That is the upper limit done. Now for the lower limit, let me just write lower limit now. Lower limit. That is when x is equal to 0, isn't it? So if I put in x equals 0 into there, then it's going to be minus 8 over 3, 0 squared, e to the minus 3 lots of 0, minus 16 over 9 times 0, and then e to the minus 3 lots of 0, and then minus 16 over 27, e to the minus 3 lots of 0. Now what happens here? Well, that there and that there are going to just cancel, isn't it? Those are just going to be zeros because of these here. So I can say goodbye, goodbye, and that will leave me with that there, which is going to be minus 16 over 27. Minus 3 times 0 is 0. So it's e to the 0, which is 1. So it's just minus 16 over 27. And that is the lower limit there. So this is the lower limit. This is the upper limit. So therefore, we can say that the answer is going to be the upper limit minus 136 over 27, e to the minus 3, minus the lower limit. Remember, put in a bracket, 16 over 27, and that is equal to minus 136 over 27, e to the minus 3. Two negatives make a positive, plus 16 over 27. And they wanted the e to the negative 3 term on the right and the constant on the left. So therefore, we're going to say that the region R is going to equal 16 over 27 minus 136 over 27, e to the minus 3. So therefore, A is equal to 16 over 27, and B is equal to negative 136 over 27. And that is it. Whoosh! That took ages. But yeah, done. Okay, so part A for question 12 says express 1 over v, 25 minus v in partial fractions. So this is just a very straightforward 2 marks that you'll get. You're going to do 1 over v, 25 minus v. This is going to equal your first constant a over the first factor v plus b over the second factor 25 minus v. And then all you do is you're going to multiply both sides by this denominator. Once I do that, v times it by v, 25 minus v, then it will cancel on that side. So be left with 1 is equal to, and then if I times that by the v's will cancel, be a 25 minus v, and then plus b, and then v. You could always think of it as just times in that one and that one and that one and that one. It's the same thing each time. So now we're here. All we've got to do is just to figure out what a and b are, we need to set these equal to 0. So first, if I set that equal to 0, then that would mean that v is going to equal 25, isn't it? So I'm going to plug in 25. That will give me 1 is equal to a, and then 25 minus 25 plus b lots of 25. And that is going to be 1 is equal to a times 0 plus 25b, which would mean that I'm going to have 1 is equal to 25b, which means that 1 over 25 is going to equal b, right? Or b is equal to 1 over 25. So we've got b. That's done. And then to get a, we're going to set the second factor equal to 0. So we need to make that 0, which will mean just v is just 0. So plugging that in, it's going to be v is equal to 0. And we're going to have 1 is equal to a, and then 25 minus 0 plus b, which we know, but I'll leave it as b for now, 0, like that. And then that will become 1 is equal to a times 25. And then 0 will just cancel. So therefore, we can say that 1 over 25 is also equal to a, or a is equal to 1 over 25. So now that I've got a and b, what I can do is just write it in that form, right? So I'm going to just now say then, final answer is going to be here. It's going to be a is 1 over 25. So I could put it like 1 over 25 v plus b, which is also 1 over 25. Like that, 25 minus v. And to be honest, it's always neater if you put the denominators in the denominators and numerator in the denominator. So these 25s right here, so this one right here and that one, you could just put it underneath of the v and the 25 minus v. So in your final answer, if you want it to be really neat, will be 1 over 25v minus, sorry, not minus, plus, sorry, 1 over 25 and then another 25 minus v. And that is going to be your answer, like that. I'll put it in a box actually, like that. And that is it. That is part A finished. Okay, so part B. It says the volume V microliters of a plant cell T hours after the plant is watered is modeled by the differential equation. dV dt is equal to 1/10 T, 1/10 V, 25 minus V. The plant cell has an initial volume of 20 microliters. Part B says find, according to the model, the time taken in minutes for the volume of the plant cell to reach 24 microliters. And this is a 5 marker. So what are they asking us to do essentially? Well, when I look at it, they're asking me to find the time taken. For me, that just means find T for a certain value of microliters for the volume of the plant cell to reach 24 microliters. We know that the microliters is V. So they're asking us to find T when V is equal to 24. Now, when I look at what I've been given, the differential equation, this is not a direct equation linking V and T together, right? There's no T, there's a dt, but there's no actual T by itself. So what does that tell me? I need to solve this differential equation, because if I did have a direct equation, then I could just plug 24 into it and then I'd be done. But I don't have that. So I need to solve this differential equation, and we do that by separating the variables. So I'll just do this here. So right here, it's got dv over dt, and this is going to equal 1 over 10 v 25 minus v. And then we need to separate these variables. And the way we do that is we divide and multiply. So I'm going to divide all of this because I want the dv's to be with the v's, and I put the constants with the dt's. So it's going to be dv over v 25 minus v. And this is going to equal, times in that dt up, will be 1 over 10 dt. And then now we can put integral signs. And then just to be a bit neater, that dv can go on the outside. So it's actually the integral of 1 over v 25 minus v dv. And this is going to equal the integral of 1 over 10 dt. So we need to integrate both of these. Now we'll do the one on the left because it's harder. And I've actually got what we did in part A in a box, because remember, this is partial fraction decomposition. The whole idea of it is you have an expression that you can't integrate. So we use partial fraction decomposition to get it into expressions that we know how to integrate. So what I'm going to do is I'm going to replace it, and I'm going to say that the integral is just actually the partial fraction decomposition, which is going to be 1 over 25v plus 1 over 25 and then 25 minus v, and then dv. And then this is going to equal the integral of 1 over 10 dt. Now, we are here. We need to integrate the left-hand side. So what we're going to do is we're going to do it term by term. So what do we have here? We have 1 over 25v. Now, the way I integrate this is I'm going to take out that constant, right? That division of 25, we can actually pull out. So it's actually the integral of just 1 over 25 and then the integral of 1 over v. which you should immediately recognize as a standard integral. This is the integral of 1 over x. Integral of 1 over x is just ln x. So this is just going to be 1 over 25 and then ln v. You can put the modulus signs in the argument just to be on the safe side. I would recommend that actually. But with this case, because the volume is increasing, right, we know that it's going to be positive. So I can actually drop them, but I'll just leave them there for now because it's always a good habit. So that's the first one. And then I'll put it in a circle just so I know that we've got that there. And then the next one is we're integrating 1 over 25 and then 25 minus v. Again, there's a 25 on the outside. I can bring that out. So it's just 1 over 25. And then we're integrating 1 over 25 minus v dv. So now, how do I integrate that? Well, whenever you're doing these types of integrals, right, when you've done the partial fractions, always remember that there's going to be a connection with the denominator and numerator, right? And that's something you should always do when you're doing these types of questions. Ask yourself if there's a connection between the denominator and numerator. And what I mean by that is differentiation. If you can differentiate the denominator and you get some sort of multiple, which is the numerator, then you could immediately figure out what the integral is. And I'll show you the rule. I'll do it here. So the rule is going to be the integral of f dash of x over f of x. This is always equal to the ln of whatever the denominator is, ln of f of x. So with that being said, if I look at this denominator here, it's 25 minus v. What do I get when I differentiate that? Well, the 25 will go, minus v will go to minus 1. So if the question, or if the integral is actually just minus 1 over 25 minus v, because the denominator differentiates to the numerator, I know that it's going to just be the ln of 25 minus v. However, we don't have a minus 1 in the numerator. We have a positive 1. So the question is, well, what is the relationship between these two integrals? Well, it's just a factor. We're just multiplying by minus 1 here, right? If I multiply that by minus 1, I get the integral that we have. Because it's an equation, I've got to do the same to the right-hand side, which would mean that this is just going to be equal to the negative of the ln of 25 minus v. So that is going to be our integral there. And that means that this is going to be 1 over 25 and then the ln, and then I'll just bring the modulus back again as well, 25 minus v. So that is the second part. So now I've got that. I'm going to put these two in circles. It's minus, isn't it? Minus there. So I'm going to put this in a circle, right, like that, because it's 1 over 25 and then there was a minus, wasn't it? So it'll be like that, right? Or you know what, just to be on the safe side, I'll just say this is equal and I'll just do this. So it's going to be equal and then it's going to be times and then that minus, isn't it? Just so it's super clear what I've done. Okay. And then that there is just minus 1 over 25 and then ln of 25 minus v. So now the two expressions in the circle are the two integrals, right? So therefore we can say that the left-hand side now, the left-hand side is going to be the first one, 1 over 25 ln of the modulus of v, and then minus 1 over 25 the ln of 25 minus v. And then the right-hand side, we need to integrate this. Well, we're integrating a constant with respect to the variable t. That is just going to be the constant times the variable, which is going to be 1 over 10 times t. So the right-hand side is just going to be 1 over 10 t, and then we add our constant of integration. Now, when we are here, we need to figure out what c is. So at this point, we call this the general solution of a differential equation because we don't know what c is. Now, to solve this differential equation and figure out what c is, we need to find the particular solution. And we do that by the initial conditions. They will always give you initial conditions if they want you to find out what c is. Now, most of the time, that is going to be implicit. It's not going to be directly given to you. They're not going to spoon feed you in the exam. So you have to just have a look. Now, have they given us anything? Absolutely. This sentence here says that the plant cell has an initial volume of 20 microliters. That word initial is key. Whenever you see that word initial, what does that mean? It means at the start, at the beginning. What is t at the start? T is going to equal 0. Right? So this is saying that when t is equal to 0, v is equal to 20. It's just a fancy way of literally just saying those two equations. T equals 0, v equals 20. That's going to be our initial conditions. And that's what we're going to use to plug in and figure out what our constant of integration should be. So before I do that though, let me just use algebra and just tidy this up a tiny bit. So I'll do this on the next page. So what I can do is I can actually take out a 1 over 25 from both of these, can't I? So it's going to be 1 over 25 and then it's going to be the ln of v. minus the ln of 25 minus v. And then this is going to equal 1 over 10 t plus c. From our log laws, right, we can actually put this as a division. Remember, the ln of a minus b is the ln of the ln of a minus the ln of b is the same as the ln of a over b. So this becomes 1 over 25 ln, and then it's going to be v over 25 minus v. It's going to equal 1/10 t plus c. Now, remember the initial conditions. When t is equal to 0, v is equal to 20. So I'm going to plug those in now to figure out what the constant of integration must be. So doing that, that's going to be 1 over 25 ln of 20 over 25 minus 20. And this is going to equal 1 over 10 and then times by 0 plus c. So therefore, this is going to be 1 over 25 ln, and then 20 over 5 is going to equal, that's 0, that's just going to be c. So therefore, c is going to equal 1 over 25. The ln of 20 divided by 5 is 4. So it's just going to be 4. And because this is a positive number, I can drop the modulus signs. So therefore, I just have c is equal to 1 over 25 ln 4. So that is our c. Now that I've got that, I can plug that in there, can't I? So that's going to be 1 over 25 ln of v over 25 minus v. And this is going to equal 1 over 10 t plus 1 over 25 ln 4. Now, what are they asking us to do? They are asking us to find, remember, they're asking us to find t when v is equal to 24. Remember, initially, we didn't have an equation linking v and t directly. We have that now. So all we need to do is plug in 24 into this. But what I'm going to do, just because I'm OCD, I'm going to just make it tidy. I'm going to make t the subject because essentially, once I do that, I just have to plug in numbers. I'm going to have to rearrange anyway at some point. So let's do that. So I'm going to move this over. I'm going to bring the ln's together. So it's going to be 1 over 25 ln of v over 25 minus v, and then minus 1 over 25 ln 4, and this is going to equal 1 over 10 t. Now we can take out the 1 over 25. So it's going to be ln of v over 25 minus v minus ln 4, and this is going to equal 1/10 t. Now inside we've got two ln's, ln a minus ln b, we know is ln a over b. So we're just doing that divided by that, right? And because we already have a fraction here, to divide it, all I need to do is bring that 4 on the denominator, right? If I divide this by 4, if I divide the yellow thing by 4, the denominator is going to be 4 times as big, isn't it? So all that means is that algebraically, it's just the same as writing the ln of v and then 4 and then 25 minus v, like that. And this is going to equal 1/10 t. And then that means that t times in both sides by 10 will just be equal to 10 over 25 ln of v over, I might as well expand that, that's going to be 100 minus 4v, like that. And this is going to equal t. And then one last thing that I can do to really simplify it is I can simplify the 10 over 25, can't I? That's just going to be 10 divided by 5 is 2. 25 divided by 5 is 5. So 2/5 ln of v 100 minus 4v. This is what t is equal to. So to find t when v is equal to 24, which is what they've asked us to do, which is just over here, find t when v equals 24, we just plug in 24 into that. So plugging in 24, that will give me t is equal to 2/5 ln of 24 over 100 minus 4 lots of 24. Like that. So plugging it into the calculator, what do we get? My calculator is here. It's going to be 2 over 5 ln of and to be fair, we can drop the modulus signs, can't we, because of the fact that that number is smaller than 100. So I can just do like this. It's going to be 24 over 100 minus 4 lots of 24, like that. And that gives me 0.7167. So t is equal to 0.7167, blah, blah, blah. Remember though, they asked us to give the answer in minutes, right? In minutes. T was in hours. So this is in hours right now. This is in hours. So to get the answer, we need to times by 60, don't we? So timesing that by 60, t is going to equal timesing that by 60. So shift answer times by 60. This gives me 43.0 blah 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 43.002, which is equal to 43 minutes. And that is our answer. 43 minutes. And that's it. Finished. Okay, so part C says show that v is equal to e to the a over e to the minus kt plus b, where a, b, and k are constants to be found for 3 marks. Okay, so I've got t from part B, right? And we need to show that that is equal to the show that, right? Now, it's just a typical algebraic problem. It's just algebra, right? We need to get v on its own. So what I'm going to do firstly is I'm going to times by 5, divide by 2. So I'm going to get 5t over 2, and that will just isolate the ln, isn't it? So I'm going to have ln of v over 100 minus 4v. Now, remember, because the show that has v equals, that tells me I need to get v, but as well as that, I've got e, right? And that tells me if you're having any problems with it, well, how can I get an e algebraically? I need to remove that ln, wouldn't I? So I'm going to take the e of both sides. If I take the e of both sides like that, then that will just be e to the 5t over 2. That e will cancel with that ln. I'm going to have v over 100 minus 4v, like that. And then, because I want v, I'm going to times up, aren't I? So I'm going to times both sides by this denominator on the right. So it's going to be e to the 5t over 2, 5t over 2 times by 100 minus 4v is equal to v. Now, because the thing that we're trying to make the subject appears more than once, we need to expand, get them all on the same side, and then factorize, just like normal changing the subject. So we're going to expand that. That's going to be 100 e to the 5t over 2 minus, and then I'll write it as 4e to the 5t over 2 v, and this is going to equal v. Moving that to the right is going to give me 100 e to the 5t over 2 is equal to v plus 4 e to the 5t over 2 v. And now we can finally factorize. So I'll do this here. So if I factorize, it's going to be 100 e to the 5t over 2. And this will equal, take out the v, you're going to have 1 plus 4 e to the 5t over 2. And then now we can divide. So if I do that, if I divide both sides, it's going to be 100 e to the 5t over 2 divided by 1 plus 4e to the 5t over 2. And this is going to equal v, isn't it? Now, if I compare with what they've got, they've got a constant on the numerator. We don't have a constant on the numerator, right? We have e to the 5t over 2. So the question is, algebraically, how can I get that? Always have what you're trying to show at hand so you can see where you are at and where you need to get to. So let me just put this here just so we have it. So putting that there. Where is it? There we go. Lovely. So we need to get that. So how can I get that? Well, what I'm going to do actually, I'm going to put the v on the other side as well, by the way. So I'm going to just put this, I'm going to just write v equals on this side. So this question is actually something that you may recognize if you've done a lot of past papers. I remember this question. This is on the sample assessment paper, paper 2, right? I think it's like question 11 or something. So stuff like this, you should actually recognize if you've done a lot of past papers. But what you want to do here is, well, essentially, because I've got a constant here, right? And I don't have one here. The question is, how can I algebraically manipulate it so I just have a constant? Well, I'd have to get rid of this e to the 5t over 2, right? So I could divide by it. However, because it's an expression, right, on the right-hand side, we need to keep it the same. So we're going to divide top and bottom by that. So it's going to be, we're going to times top and bottom by the division of that. So e to the 5t over 2, 1 over e to the 5t over 2, and this is going to be 1 over e to the 5t over 2. And then now, if I was to work that out, that will give me v is equal to, that will cancel with that, wouldn't it? You just left with 100 at the top. On the denominator, you're going to be left with that times that. You're going to do 1 times that, which is going to be 1 over e to the 5t over 2. And then plus, that will cancel with that, wouldn't it? When you times them together, you just left with 4. So we are here. That's 100 over 1 over e to the 5t over 2, we can bring that up and make it a minus. So it's e to the negative 5t over 2, and then plus 4. And now we have that form. So we can see quite clearly that A is equal to 100 and B is equal to 4. And as I was saying before, this is a very common question. This here is what we call the logistic growth model. And we like to have it in this form because it's just easier. You get rid of the e's at the top. You can see what the limit is, so on and so forth. So you should recognize this type of expression here. But yeah, that's part C. Let's go into part D now. Okay, so part D says the model predicts that there is an upper limit L microliters on the volume of the plant cell. Find the value of L given a reason for your answer for 2 marks. So, as I was saying before, this type of form is very, very common. It's the logistic growth model, which is used in biology and chemistry. It's very, very popular right now. The reason why we have it in this form is because it's very easy once you know what you're doing to see what the upper limit is, right? Now, when they say that there's an upper limit, it means, well, as time is going on, V is going to approach a value. So basically, you want to figure out what V is as t gets incredibly large or as t tends to infinity. And what I like to do when I do these is rewrite it like this. I'm going to rewrite this as 100, and then I'm going to rewrite the e to the minus as 1 over e to the 5t over 2 plus 4, right? Now, what we want to ask ourselves is, what is V? What is V as t tends to infinity, right? Let's do that. So let's write lim as t tends to infinity of that expression. It's going to be 100 over 1 over e, and then because it's tending to infinity, I'm just going to write infinity here, plus 4. Now, the reason why I'm writing it like that is because, well, it's 1 over e to the infinity. E to the infinity is just a very, very big number. So the denominator is massive. What's 1 divided by a very massive number? Eventually, it's going to tend to 0, right? So I'm going to put a 0 here, and I'm going to put plus 4, which means that it's just 100 divided by 4, which is equal to 25. So therefore, L is equal to 25, right? And again, if you don't really like this way, if worst comes to worst, just put a really, really big number into your calculator and you'll get 25 as well. So you could do it that way. And yeah, that's it. This question actually, what I want to say is very similar. I think I said it earlier in part C. It's very similar to a sample assessment question paper 2. Sample assessment material paper 2. Definitely have a go at that question. I'll put it here so you can see it as well. But yeah, definitely have a go at it. And yeah, that is it for question 12. Finished. Okay, so question 13 says the world human population, p billions, is modeled by the equation p is equal to ab to the t, where a and b are constants and t is the number of years after 2004. Using the estimated population figures for the years from 2004 to 2007, a graph is plotted of log base 10 of p against t. The points lie approximately on a straight line with the gradient 0.0054, the intercept 0.81 on the log base 10 of p axis. Part A says estimate to 3 decimal places the value of A and the value of B for 4 marks. So I've just got this summarized, the things that we need for part A just underneath here anyway. So to do this, I'm a visual learner, so I would actually just draw a diagram. So I'm going to draw a diagram. I'm going to draw an axis like that, right? Now, we know that we've got 2 axes. We've got the y-axis, which is essentially log base 10 of p. And obviously t is the independent variable because it's time. So that definitely goes on the horizontal axis. And they've told us that we've got a line with a gradient of 0.0054, which is greater than 0. So it's going to go up a little bit, right? And the intercept is 0.81, right? So 0.81 over there. And the gradient is 0.0054. We need to figure out what A and B are in this model here. So there's a couple ways to do it. I'll show you both. What I would do just initially is I've got a line, right? And I'm going to change the color here. Let's say this was a Y and let's say this was an X instead of these here. Then what would the equation of this line be? Well, Y equals mx plus c. It's going to be Y is equal to, the gradient is 0.0054. The variable is obviously x, and then plus the intercept, which is 0.81. That would be the equation of the line if it was y and x, right? However, it's not. But that's not a problem. You're just going to replace it, right? The y-axis or the y variable is log base 10 of p, and it's 0.0054. The x variable is t. The intercept is 0.81. Right? So I get this here. Now, because I want to figure out what A and B are, I could use algebra, manipulate this to get it in this form, and that way I can just compare it essentially. So that's one way of doing it. I'll do it. So firstly, because I want P on its own, I'm going to get rid of this log. This is a log of base 10. So you're going to raise both sides with a base of 10 like that. And essentially what will happen is that that will cancel with that. That will become the power. So it becomes P is equal to 10 to the power of 0.0054 t plus 0.81. They both go in the power. And then from our index laws, we have a sum in the power. We can write this as a product. So 10 to the 0.0054 t times by 10 to the 0.81. And then another index law, we've got a product here in the power. We can write one of them inside, one on the outside. Because it's b to the t, I want that power of t to be on the outside. So it will be p is equal to 10 to the power of 0.0054. That's going to go inside, and then it's going to be to the power of t. And then times by 10 to the power of 0.81. And then now I'll just write this here. To finish off, let's write it the right way. So it's going to be P is equal to 10 to the power of 0.81 multiplied by 10 to the power of 0.0054 all to the power of t, isn't it? Let me just move this arrow a bit. So it's like that. And then if I compare it now, I have this is P, this is equal to A, this is B to the power of t. So we can see quite clearly that A is going to equal 10 to the power of 0.81 and B is going to equal 10 to the power of 0.0054. So just putting that into the calculator, what do we get? We are going to get 10 to the power of 0.81. That will equal 6.456. What do they want it to? The three decimal places. So 6.457. So A is going to equal 6.457 and B is going to equal 10 to the power of 0.0054. And that is equal to three decimal places 1.013. 1.013. Let me just double check those are all good. Yes, that's it. Perfect. So that is A and that's B, and that's one way of doing it. Another way you could have done it, and you guys can let me know which way you prefer in the comments, is you actually start off with P equals AB to the T. So I'll do it here. I'll write V2 for version 2. You start off with P equals AB to the T, and then you're going to use your log laws to basically get it in the form of y equals mx plus c. And then again, you just compare. So let's do that. We take the log of both sides. So it's going to be log base 10 of p is equal to log base 10 of ab to the power of t. And then we can write log base 10 of p. We have a product here, a times b to the t. So we can split this into a sum from our log law. So log base 10 of a plus log base 10 of b to the power of t. And then one more log law, p is equal to log base 10 of a, and then plus, and then that power of t can drop to the front. So it's t log base 10 to the power of b. Now we want it in the form of basically, I'll write it here, y is equal to mx plus c, right? And that tells me that, well, a is a constant, so log base 10 of a is a constant, so that's going to be our c, so that would go there, log base 10 of a, and then obviously we've got the variable t, and we're timesing it by this number here. This has to be the gradient, so this is going to be the gradient, which is log base 10 of b, and I put this in a bracket, and then that's going to be t, and then this is going to be your y, so log base 10 of b. And then from here, because of the fact that I've got in that structure, I can use the information in that diagram, right? We know that the gradient is 0.0054. So therefore, this is the gradient here. This is the gradient 0.0054. And then the y-intercept we saw was 0.81. So that can go there, and then you get the same thing essentially. You get log base 10 of B is equal to 0.0054, and then log base 10 of A is equal to, A is equal to 0.81. And then you just solve both of these the way you would normally do it. Just take 10 both sides like that. That will cancel with that, and then that would have that there, and then the same thing like that. That will cancel with that, and then you have A is equal to 10 to the power of 0.81. The same thing that we got before. So that is the other way of doing it. And then now we'll go into part B. Okay, so part B, it says in the context of the model, part I says interpret the value of the constant A. So I've got the model with our values of A and B here, and then I've just got the context of the question underneath because we're going to need it, right? So whenever they ask me to find a constant A, or interpret the value, I should say, you actually want to find out or figure out what value of T that would actually represent. What would A represent? You've got P equals AB to the T. If T is equal to 0, then we're going to have P is equal to A B to the power of 0. B to the 0 is 1, so P will equal A. So the constant A is for a certain time, right? It's for when T is equal to 0 at the start. So what does that mean in the context of this question? It's the population at the beginning, right? So for B, I, right? A is when T is equal to 0, right? So what you're going to say is this represents the population in billions in, remember, this model is T is the number of years after 2004. So at the start, it's at 2004. It's in 2004. So this represents the population in billions in 2004. Just make sure you write in billions as well, because that's what P represents, right? So that would be I. Now, double I, what does it say? It says interpret the value of the constant B. Now, B is that number there, isn't it? B is equal to 1.013, and it's that number, right? If I get the model again, 6.457 times by 1.013. Remember, T is your number of years. This here is your multiplier. It's your annual increase, right? It's what you multiply to increase the population year on year, isn't it? Because if you think about it, after 1 year, your population would be that much. And then after 2 years, you would do 1.013 to the power of 2. After 3 years, it'll be 1.013 to the power of 3, and so on and so forth. You can even think of it as the common ratio in the geometric sequence, right? So what you're going to say is that B represents the annual, or the multiplier for the annual growth, I should say, represents the multiplier for the annual growth of the population of the population. So yeah, that's literally if I times that by 100, then that would be 1.01. Whoops, that's funny. It would be 101.3, isn't it? Right? And that would mean that your percentage increase is 1.3%, right? So 1.3 percentage increase. So it's basically saying that the population is increasing by 1.3% each year. So that's double I. That's what you would say represents the multiplier for the annual growth of the population. So that's double I. Part C says use the model to estimate the population, the world human population in 2030. So remember, our model is for T number of years after 2004. So 2030 is going to be 26 years later. So all you're going to do is literally plug in 26 for T, and that will be your answer. So let's do that here. So part C is going to be P is equal to, what was A? 6.457, wasn't it? Yeah. 6.457 times by 1.013 to the power of 26. So I'm going to put it in the calculator and see what I get with that. So 6.457 times 1.013 to the power of 26 This gives me 9.0 34, right? All right, to 3dp. To 3dp. So therefore the answer is 9.034 billion, isn't it? Because P is in billions. So that would be the population after 26 years in the year 2030. So that's part C. Part D says, comment on the reliability of your answer to part C. So again, I got the context of the question because it's important. Is that a reliable answer? Remember what the context said. The context, right, tells us that the data that we found when we got this graph here, there was for the years, where was it? It was for the years, it was an estimation, it was an estimated figure for the years between 2004 and 2007. So this graph that we found was based on those years, 2004 to 2007. Who's to say that that relationship will continue year in, year out up until 2030, right? It's too far outside the range, right? We're extrapolating at this point. So what we're going to say to finish off, we're going to say, this is unreliable, reliable, as 2030 is far outside the range of data. Now, right, 2004 to 2007, we would be extrapolating, extrapolating. And then you could just write a rhetorical question. Who's to say the relationship will continue? So far after 2007. So far after 2007. Imagine an examiner sees that, you have to get the marks. You know, with these types of questions, you've got to be clear. There's no way an examiner will read that and be like, there's something wrong with that. That is perfect, right? So that will be it for part D. And that is it for question 13. Done. Okay, so question 14 says the circle C1 has equation x squared plus y squared minus 6x plus 14y plus 33 is equal to 0. Part A says find the coordinates of the center and the radius of C1, right, for 3 marks. So I've just got that summarized underneath here. So this is just a matter of getting in that form when you complete the square. So what I'll do for part A is firstly I'm going to group the x's and y's together. So it's going to be x squared minus 6x plus y squared plus 14y plus 33 is equal to 0. Now we want to complete the square on each of these, don't we? So that's going to be x, half the coefficient minus 3, take away the square, so 9, plus, and then half the coefficient of 14 plus 7, take away the square, 49, plus 33 is equal to 0. And then what do we have here? We've got minus 9, minus 49, plus 33. That is, let me do x minus 3 all squared, plus y plus 7 all squared. That is minus 58 plus 33, no? That is 50 take away 30 is 28. This is 25. This is minus 25. So I've got x minus 3 all squared plus y plus 7 all squared. Take away 25 is equal to 0. Add it on. So I'm going to have x minus 3. Hold on, this looks messy. So we have x minus 3 all squared plus y plus 7 all squared is equal to 25, right? And then what I'm going to do is I'm going to square root the 25 and make it 5 squared. So it's going to be x minus 3 all squared plus y plus 7 all squared is equal to 5 squared. And then if we compare this with the format of x minus a plus y minus b all squared is equal to r squared, then we can see quite clearly what A and B are, what the center is, and so on and so forth. So like that, the center is going to be, that's going to be a 3. That's a plus 7, so we do the opposite. It's going to be minus 7 like that. The radius is 5 because that is r, right? So the radius is equal to 5. So this is part I, and that's part II. And that is literally it for part A. I think that's it, no? Very, very easy, 3 marks. So yeah, let's go into part B. Okay, so part B says a different circle C2 has center with coordinates -6, -8, has radius k where k is a constant. Given that C1 and C2 intersect at 2 distinct points, find the range of values of k, write in your answer in set notation, and this is 5 marks. Okay, so what I've just got here underneath is I've just got what we did in part A summarized. We got this circle C1, which has a center 3 -7, the radius is 5, and we got the radius, and we got the equation for the circle as well. So what I would do, just by looking at the sentences, I would just immediately figure out what the equation of circle C2 is, right? Just so I have it for reference. Now, that's the center. That's a -6, so that's going to be x plus 6, isn't it? Right, just to get the -6 there. Similarly, it's going to be y plus 8 to get the -8 for y. And then the radius is k, so it's going to be k squared. And this is the equation for C2. Now, when I look at this, right, you may be tempted to think to yourself, okay, well, find the range of values. Okay, we've got two algebraic equations, quadratics because they're squares. Maybe simplify, substitute one into another, use of discriminant. However, because of the fact that typically when you're dealing with those, you normally have a linear equation and a quadratic. It's easier that way. This one has both quadratic, so it's going to be quite messy. So what I would do is try and visualize this question. And because it's part B of question 14, the second to last question, there's probably some geometric way of doing these questions as well. If you've done another, if you've done enough of these questions, you'll start to notice the patterns. So what I've done here is I've got axes going, and I want to attempt to visualize the circles, right? So the first one, C1 has a center of 3, -7. So let's put that in. So let's just say, for example, 3 is over there. Let's say -7 is over there. Let's say this is the center. Now, how big is this circle? Well, we know the radius of it is 5, right? So, for example, that tells me, well, this is a 3. This horizontal distance from the center to the y-axis must be 3 units too. Because the radius is 5, I know that the circle is going to go past that y-axis. So it's going to lie in both the third and fourth quadrant. It's going to lie underneath the x-axis. So I'm going to get a circle going, and I know for sure it's going to go past that y-axis. So let's just say, whoops, what happened? What happened to the circle? There we go. Oh, I've got the rubber, that's why. Let's just say it's like that. And then as well as that, we know that this distance here from here, whoops, there's my pen. This distance from hair to hair is 7 units, isn't it? Since the radius is 5, which is less than 7, I know for sure that it has to lie underneath the x-axis 100%. So I know that the circle is going to be roughly like that, right? So I'm going to put, let me rub this out. Let me put the center in here. So this is going to be 3, -7. Now we have the other circle. This is C1, by the way, right? Now, we've got the other circle, which, where's the question gone? There we go. Is C2, which is x plus 6 all squared plus y plus 8 all squared is equal to k squared. We got the center is -6, -8, and the radius is k. So let's draw that in as well. So let's just say if that's 3, let's just say -6 is, I don't know. Let's say -6 is like there. And then let's say 8, -8, let's say -8 is just there. So let's just say -8 is there. So let's just say the center of that circle is there. And then let's draw this circle. This circle we know has a radius of k, right? We don't know what k is, but remember, they've said that they want the two circles to intersect twice, doesn't it? So if I was to just extend this, then that would be a circle with center 6, -6, -8 that intersects twice, right? Now, what you want to do is think about the critical values. What about if the circles were just to touch, for example? So let's just say I had if I made the circle a bit smaller like that, and then I just drop this lower like that, then I've got a circle which just touches, right? They only intersect once though. So we don't really want this. However, it's a good point of reference because any circle bigger than this, right, which would imply that the radius is bigger than k, would allow this circle to intersect twice, isn't it? If I make this slightly bigger, it intersects twice. So the critical value here is, well, I want to ask myself, well, what is that radius? Because if I know what that radius is, right, then I know that anything bigger than that will make it intersect twice. The two circles will intersect twice. Now, how do I go about doing that? Well, if you think about it, we know what this is. This is minus 6. That's the center of circle C2. Let me write that. For us to be able to figure out what that value k is, well, if you think about it, if I start from this point here, I'm going to draw a line. So if I start from here, this center, and I draw a line to the other center, if I could calculate that distance there, then that would allow me to figure out what k must be, isn't it? And we can do that because of the fact that we've got the two coordinates. So let me just draw a line again, just so it's neater. Will it go straight? Yes, perfect. I want to figure out what that distance is. Let's say I call this point A, and let's say I call this point B. We know that this distance here, because it's just touching at the moment, is a k, right? That's the radius. And in this distance here is the radius of the circle C1, which we know is 5, right? So I've got the green plus the blue, that's k plus 5. K plus 5 in this case, when they just touch, would have to be equal to the distance from A to B, which in other words is the distance of, or the magnitude of A to B, isn't it? Right? If I could work out the magnitude of A to B, then that would make me be able to find out what k is, right? And you can do it a couple of ways. You can do it as a vector, which I'm about to do, or you could just do the difference formula for two coordinates. I'm going to do the vector version though. So A to B, if I do it in terms of a vector, I do it in a column vector. X coordinates, I want to go from a -6 to a +3. That means it's going to be 9, right? The y coordinates, I want to go from a -8 to a -7. That's going up by 1. So it's going to be 9, 1. So therefore, the magnitude of A to B is literally just going to be equal to the square root of 9 squared plus 1 squared, isn't it? Which is going to be 81 plus 1, which is 82. So therefore, this here is actually equal to the square root of 82. So what I'm saying here, essentially, I'll just draw it out one more time so it's super clear. This line at the top here, this is A, this is B. This is k plus 5, and I know that this distance here is going to be root 82. So I can say that k plus 5 has to equal root 82. And that would mean that k is going to equal root 82 minus 5. And that is going to be our critical value, because what we're saying here is once k is equal to root 82 minus 5, the circles touch, as you can see. The moment I increase the circle, i.e. increase the radius k, right, then the circle will intersect twice, wouldn't it? Right? So therefore, I can say that my critical value is k equals root 82 minus 5. And so therefore, I can say that k must be greater than root 82 minus 5 for it to intersect twice. So that's one part of it. Now the next part, okay, remember, we have a lower limit, right? But if there's no upper limit, for example, k would get so big to a point where it would literally just engulf that smaller circle, right? Because if you think about it, I could create a circle that's bigger and that has that same center. Let me just draw it a bit bigger. Let me just draw it like that. Let's say it's like that. We still have that circle, right? Which has the center 6 minus 8, but you can see now it's gotten so big that it's engulfed it. And there's another section, or there's another scenario whereby it just touches it once. The first part, when it was like this, which we've just calculated, when the circles touch on the outside like that. And the second part is this part, right, where it touches again once. So the question is, what must the value of k be for the circle to be that big? Because if you could figure out that, that would be the upper limit, wouldn't it? Now, how do we do that? Well, again, this is really not that bad, because if you think about it, I'm going to just highlight this here. We know that the distance of A to B, right, this yellow distance here, this is the square root of 82. We've calculated it already, right? That's the square root of 82. Now, the center is at A. The radius would then extend, wouldn't it? Right? The radius would extend all the way here, like that. That distance in pink is just the center B to the side, to the end of that circle. That is going to be the radius too. This right here, that right there is going to be 5 as well, right? Because that is the radius of the circle C1, the smaller circle, okay? which would mean if I draw another diagram, right, just to signify or just to write that distance there, I'm going to do it like this here. When it's larger like that, then this point is A, like that. And we know that this point here is a B. And we know this is root 82, like that. And then this is 5, isn't it? So altogether, this whole distance is root 82 plus 5. And then again, having a look at the diagram, right, we can see that, well, for that circle to engulf it and then just touch it on the outside, the radius of the circle C2, which is in terms of K, that would have to be root 82 plus 5, wouldn't it? Root 82 plus 5. So what I can say then is that the upper limit is when K is equal to root 82 plus 5. Like that. So let's just summarize what we've done here, right? So again, the lower limit, remember we want the circle to intersect twice. So we've got a circle like that. The first scenario is when they just touch. Can I make that a circle? Hopefully I can. Let me try one more time. If I just do that, will it make it a circle if I hold it? Yes, perfect. So that's when they just touch like that. And then remember we said that K in this case, I'm going to do it like that. This is K over there. And then this here is the center. And then this was a 5. And then remember, this was A, that was B. This is root 82, like that. So this one, scenario 1, this is when K is equal to root 82 minus 5. And in the second scenario, which you've just seen here, when the circle engulfs it, right, and then it touches it on the outside, is when it looks like this. So I'll just draw that circle again like that. And then I'll draw another circle like that. You guys will get the picture, hopefully, I'm sure. And then this is the second scenario like that when it basically engulfs it. Okay, and let me just make sure it touches like that. And then this one here is when the center is basically, let's just say it's like here, just it's a sketch, isn't it? Or you know what, I'll make it smaller so it makes sense. Make this smaller like that. So basically, yeah, that's better. So the center in this case is going to be like there, and then that radius there we've seen, hold on, that radius there is going to be root 82 plus 5, like that. And that is when K is equal to root 82 plus 5. But remember, we don't want these values of K because at these two scenarios, right, scenario 1 and scenario 2, the circles are only intersecting once. So we want it to be inside, right? So therefore, the range of values of K is going to be when K is bigger than scenario 1, so root 82 minus 5, like that. And at the same time, it would have to be less than scenario 2 when K is less than root 82 plus 5. Now, they asked us for it in set notation. So what I can do very, very easily is say, well, all you got to do is squiggly set K such that K is greater than root 82 minus 5, and then close bracket like that, and is intersection. And then the same thing here, K such that K is less than root 82 plus 5, like that. So that would be fine. Or you could just write it as one inequality because it's K is greater than K less than, so you can join it. So you could just literally say such that K, and then K in the middle, and then root 82 minus 5 on this side, and then root 82 plus 5 on that side. And that would be your final answer. And that is it. So I wonder how long that took me. But yeah, that is it for question 14. Done. Okay, so question 15 says the curve C has equation x plus y all to the power of 3 is equal to 3x squared minus 3y minus 2. Part A says find an expression for dy dx in terms of x and y for 5 marks. Now, we need to differentiate because they're asking us for dy dx. When I look at the curve, right, what do I see? I don't see y explicitly in terms of x, right? I see x's and y's on both sides. So for me to be able to differentiate this, I need to use implicit differentiation. So that's the first thing. As well as that, when you see in terms of x and y, that is a classic giveaway as well, that this is an implicit differentiation question. So now that we've got that out of the way, we know that we're implicitly differentiating. Now, when I look at this, I'm not really familiar, or not me. Come on, I know everything. I'm joking, but you don't really see these types of questions whereby you've got a power of three, right? So you may be tempted to be, okay, well, I could just expand it out and then do it term by term, but you don't really want to do that because it takes a bit of time. And you don't have to do that, right? Because, for example, let's say there wasn't a y, then it was like, for example, x plus one all to the power of three, and I asked you to differentiate that. I'm sure you would tell me that this is just a chain rule problem, right? You just see the outer function is three, so the outer function is x cubed, sorry. So you're gonna differentiate like that, bring the power to the front, drop the power by one, and then you're gonna multiply by the derivative of what's inside. X plus 1 will differentiate to just 1. So that would be the derivative of x plus 1 all cubed. You don't need to expand it. You can do the same thing here. You just got to be very careful because when you get to this part inside, you've just got to differentiate that implicitly. Yeah? So we're going to do that. We're not going to expand that because no one's got time for that. I'll be real. So what I'm going to do, I'm going to do the left-hand side. So x plus y all cubed. If I want to differentiate that with respect to x, similarly to what we just did above, we bring the power to the front, 3, x plus y, keep the bracket the same, drop the power by 1, and we're going to multiply by the inside derivative. So when I differentiate x, I get 1. When I differentiate y, you first differentiate y with respect to y, which is just going to be 1, and then you multiply by dy dx. So it'll just be 1 times dy over dx. And then that just simplifies to be 3x plus y all squared times by 1 plus dy dx. And that is the left-hand side differentiated. Now the right-hand side is a little bit more straightforward. 3x squared minus 3y minus 2. 3x squared minus 3y minus 2. If I want to differentiate that with respect to x, then the 3x squared is just going to be 2 drops to the front, 6x. And then the minus 3y, we differentiate with respect to y. That will just be minus 3. And then we multiply by dy dx. So it's going to be minus 3 dy dx. And then the minus 2 will just disappear. So that is the right-hand side. So this is the LHS, left-hand side. This is the RHS, right-hand side. So now we've differentiated both sides. We can equate them. So therefore, it's going to be 3 bracket x plus y all squared. And then times by 1 plus dy over dx. And then this is going to equal the right hand side, which is 6x minus 3 dy over dx. Now remember, we want dy dx. So now it's just a matter of algebra, right? So again, we have this bracket of x plus y all squared, right? You may be thinking I need to expand that. You don't need to. If you just treat this as one term, which you absolutely can. If I was to expand, imagine that was a capital A, then it would just be a times 1 plus dy over dx. And then you would just expand that normally. It would just be a times a dy dx. So I'm just going to expand it like that. I'm going to just do that times that and then that times that. Let me move this out of the way, actually. Let me write that out there. So it's just literally, just think of that as one term. You're going to do that times that and then that times that. So that would become 3x plus y all squared times by 1 would just be the same thing, wouldn't it? So it'd just be 3x plus y all squared. And then this one will just be plus that thing, which is 3x plus y all squared. And then we will times by dy dx, wouldn't we? So that's the left-hand side. And then let's write the right-hand side. And remember, we want dy over dx. So now it's just a matter of just algebraic manipulation. It's kind of like changing the subject of the formula. We want to isolate that dy dx. So just like you would rearrange something which appears more than once, you're going to move everything with dy dx onto one side, everything without it onto the other, factor it out and then divide it and blah, blah, blah. So that's going to go to the left. This doesn't have a dy dx in it, so that's going to go to the right. So that way it will become 3x plus y all squared dy over dx plus 3 dy over dx. And this will equal 6x, and then I'm taking that away, aren't I? So it's going to be minus 3 x plus y all squared. And then now we can see dy dx appears there and there. We can factor it out, can't we? So we're going to have dy over dx, and then in the bracket it's going to just be 3x plus y all squared plus 3, and that will equal 6x minus 3x plus y all squared. And then now we can just divide that, can't we? So if I divide that on both sides, I'm going to have dy over dx is equal to 6x minus 3x plus y all squared. And then we're going to divide this by 3x plus y all squared plus 3. And then now, this is dy dx, but can you simplify it? Absolutely. Because if I look at it, I've got a 6 here, I've got a 3 there, I've got a 3 there, I've got a 3 there. There's a common factor of 3 everywhere. So if I divide every single thing by 3, then that 6 will go to a 2, so it'll be 2x. Minus that 3 will disappear, it'll just be x plus y all squared. And then divide this by, the 3 will disappear, it'll just be x plus y all squared plus 1. And this here is going to be your answer for part A. This is dy dx, and this will give you 5 marks. Fantastic. So we've done that. Let's go to part B. So what does part B say? Part B says the point 10 lies on C. Show that the normal to C at P has equation y is equal to minus 2x plus 2. This is only 2 marks, so this is not too bad. So let's get that. And then let me put this down here, and then I'll get dy dx as well because we need the normal, so we know that we're dealing with gradients. So yeah, so we've got that. That's the question. And then where's dy dx? Dy dx is that thing, isn't it? So let me grab that and then put that here. So we want the normal, don't we? So we need to figure out what the tangent gradient is first, and then find the negative reciprocal. So I'm going to write dy dx is that. We know that when we're looking for a normal, the normal line, right? Let's just say n is normal. I'm going to say we've got x1, y1, and then n is the normal gradient. The general formula is just going to be y minus y1 is equal to n x minus x1, right? So we're halfway there because we've got the point 10. So it's going to be, let me write 10 here. That would mean it will become y minus 0 is equal to n x minus 1. So the question is, what is n? How do we find out what n is? Again, n is the normal gradient. So we need to figure out what the tangent is by plugging in our point P and then taking the negative reciprocal. So if I plug in 10, I actually saw my good friend Marv, Maths with Marv, he used this notation where you put dy dx 10 here. So shout him out, follow him on all socials. Best mathematician I've ever seen in my life. Anyways, what are we doing? So we're going to plug this. It's going to be 2 lots of x, which is 1, like that, minus, and then 1 plus 0, all squared, like that. So that's 1 plus 0, that's fine. And then that's going to be 1 plus 0 again, all squared plus 1. Is that correct? X equals 1, that's fine. X equals 1, y is 0, that is fine. So what's that? That is 2 minus 1 squared, that's 1, over 1 squared is 1, that's 1 plus 1. That is 1 over 2. So the gradient of the tangent is a half. Tangent is a half. The normal is going to be the negative reciprocal of that, which is minus 2. So therefore, we can plug that in. So we've got n is equal to minus 2 now. So we can say that it's y minus 0 is equal to minus 2 x minus 1. Y minus 0 is y. Expand that bracket, that's minus 2x plus 2. And that's it. That's 2 marks. Done. And let's go into part C now. Okay, so part C, it says prove that the normal to C at P does not meet C again. You should use algebra for your proof and make your reasoning clear. And this is another 5 marker. So I've got part B here just because we're going to need it, right? So, and I've also got the curve C as well. So let's read part B again. It said that the point P10 lies on C. Show that the normal to C at P has equation y equals minus 2x plus 2. So we have the normal to C at P. The normal to C at P is there. The normal to C at P is there. We know what that is. That is y equals minus 2x plus 2. So I'm going to write that there. And in part C, it says, prove that that normal does not meet C again. C is the curve, right? So I'm going to write this here. X plus y all cubed is equal to 3x squared minus 3y minus 2. That word meet, that's another way of saying intersect, right? How do we show when two lines or curves meet? we solve it simultaneously. So what we need to do is solve this simultaneously. We've got equation 1, we've got equation 2, and let's read it again. They've told us that it does not meet again, right? We know that it met in part B, right? Part B told us that the point 10 lies on C. So we know that it meets. The fact that it says it doesn't meet again, that implies that there's going to be how many solutions to this simultaneous equation? Only one, the one that we have already. So the reason why I've put part B here is because these questions are scaffolded, right? They're broken down deliberately to guide you through. Think of these questions as a storyline. Part B has told you something about point P, the normal, and in part C they're building on that. So you always want to just think of this as a storyline and just try and work your way. Okay, so let's think of that logic. We know that we have a simultaneous equation. They've told us it doesn't meet C again. We know that it met C once at point B, in part B. So I know that when I solve this algebraically, I should expect to get one solution, right? So let's just have that in our minds. So how would we solve this simultaneously? Well, this is a linear equation. It makes sense to just plug that in for y, isn't it? So I'm going to say sub 1 into 2. That would give me x is just x, so x plus, and then y is minus 2x minus 2x plus 2, like that. And then that's all cubed, and then that's going to equal 3x squared minus 3 lots of y, which is minus 2x plus 2, and then minus 2, isn't it? And then that there, that's going to be, to be honest, that bracket can drop, isn't it? If I get rid of that minus, I can literally write like that, isn't it? It's just going to literally be that x minus 2x plus 2. That would simplify to become, I'll bring the positive 2 at the front just because it looks neater. So 2, x minus 2x is a minus x. So that would be 2 minus x all cubed. And then this will equal 3x squared. And then expanding that bracket is going to be plus 6x. And then that would be a minus 6, isn't it? Minus 6, minus 2, like that. So we're here. Let's tidy up the right hand side. It's going to be 3x squared plus 6x minus 8. And then to be honest, that's a cubit. Let's expand that. So let's do this over here, like that. And then that is going to be, that's going to be 2 minus x, 2 minus x, and then another 2 minus x, isn't it? So what's the best way to do that? We can just, let me move that here. I'll expand two of them. So if I expand these two like that, then that is just going to be, that would be 2 times 2 is 4. That would be minus 2x, and then another minus 2x, which would be minus 4x. And then minus x times a minus x would be a plus x squared, like that. I've just skipped the subtle step. So you remember, when you expand this, you can do it in your book. You would have a minus 2x and then another minus 2x. That would be the minus 4x. So I've just skipped that step slightly. And now we have 2 minus x, and that will equal 3x squared plus 6x minus 8. Now, what do we have here? Let's expand. Let's do, you know what I'm going to do? I think it's going to be easier for me anyway. Let me put this bracket on the left side. I think it'd just be easier for me to look at. Hold on one sec. So move that there. And then I'm gonna, hold on. I'm gonna move this just like that. And then that one needs to go over there. I need to get that bracket, move that there. Like that. Yeah, like that. Okay. So yeah, I'm gonna expand it like that. And then I think that's just, it's just easier for me to look at when I've got it that way. So that's gonna be 2 times that is going to be equal to 8 minus 8x plus 2x squared minus 4x plus 4x squared minus x cubed. And that will equal 3x squared plus 6x minus 8. Now, tidying up the left-hand side is going to be, well, what do I have here? I've got a minus x cubed, which I'll put at the front. I've got x squared. I've got 2x squared and then 4x squared. That'll be 6x squared. And then I've got a minus 8x and another minus 4x. That'll be minus 12x, wasn't it? And then the only constant there is the 8. So that would be there. And then that will equal 3x squared plus 6x minus 8. And then let's move everything from right to left. So that will give me minus x cubed. If I move that 3x squared over like that, that would be a plus 3x squared. If I move that 6x over, that would be a minus 18x, wouldn't it? And then that minus 8 would be adding on to that 8. That would be plus 16. Now equals 0. And it's a cubic. I'm going to just times through by minus 1. So the x cubed term is positive. So it's going to be x cubed minus 3x squared plus 18x minus 16, isn't it? Is equal to 0. Let me just double check. That looks good to me. That looks good. That looks good. That looks good. Okay, perfect. So now, remember, we're trying to solve this, right? Remember, it says prove that the normal to C does not meet P. The normal to P does not meet C again, meaning that there's only one solution, right? Which we know in part B, the point P 1, 0. So essentially, there's only one solution here, right? So I'm going to just write there's only one solution based on the fact that it says it doesn't meet again. Now we know where that solution is. That solution was when P is at 1, 0. Or in other words, when x is equal to 1, right? So what that means is that if I plug in 1 into here, I should expect to get 0 out. So let me actually do that and let's see what happens. If I plug in 1, I'm going to have 1 cubed minus 3 lots of 1 all squared plus 18 lots of 1 minus 16. What's that? That is 1 minus 3 plus 18 minus 16. That is 1 minus 3 is minus 2 plus 18 minus 16. That is minus 18 plus 18, which is equal to 0. Does that remind you of anything? We plugged in the value into a cubic and we got 0 out. You should be thinking of the factor theorem, right? Now, the reason why that's very helpful is because of the fact that because it's equal to 0, we can use the factor theorem and we could say that x minus 1 is a factor due to the factor theorem. Let me write due to the factor theorem. All right, so as you can see, this is question 15 of a paper, the last question, and you're using something that you taught in year 12, probably in September or October of when you started your A levels. So you can see that you have to use everything with these questions, okay? Now, why is that helpful? Remember, they've asked us to show that it doesn't meet more than once, right? There's only one point of intersection, which we know. So what we'd want to do is factorize this cubic as much as possible and show that there's only one solution, right? The thing that you're typically doing when you're doing the factor theorem, right? So because I've got that, I know that x minus 1 is a factor. I can use long division to figure out what the quadratic factor must be. So let's go ahead and use long division with that. So I'm going to have x minus 1 and I'm going to divide it by, what was the cubic? It was this one right here. This one right here. X cubed minus 3x squared. 3x squared plus 18x minus 16. We're going to use long division to figure out what the quadratic factor must be. So we do this term x cubed divided by x. That is x squared. That goes on the top. And then we times this x squared term by the factor that we're dividing by. So x squared times by x is an x cubed. X squared times by minus 1 is a minus x squared. So that goes there. We take these away. That will be 0. Minus 3 minus minus is minus 3 plus 1. That's going to be minus 2x squared. Like that. We drop that down to be plus 18x and we just repeat the process. Minus 2x squared divided by x is going to equal minus 2x. That would go there. And then we're going to times the minus 2x by this factor that we're dividing by. Minus 2x times the x is going to be minus 2x squared. And then minus 2x times that minus 1 is going to be a plus 2x, isn't it? Like that. And then we're going to take away. And then again, those will cancel. 18 minus 2 is 16. So I'm going to have 16x here. Drop that down, minus 16. And again, repeat the process. I have 16x over x is equal to 16. So that would go there, wouldn't it? And then now, that 16 on the end, we're going to times by x minus 1. 16 times x is 16x. 16 times minus 1 is minus 16. Now we can see that those cancel. We get 0. So it means that it's a factor, right? There are no remainders. It's a factor. So therefore, our cubic, which was what? X cubed. What was it again? X cubed minus 3x squared. X cubed minus 3x squared plus 18x. 18x let me write this again. 18x plus 16. This is actually equal to, let me just make sure I've written it again. X cubed minus 3x squared plus 8x. Yeah, fine, perfect. This is actually equal to x minus 1 multiplied by x squared minus 2x plus 16. Now, remember what they asked us to show. They asked us to show, or prove, I should say, that there's only, that the curve and the line don't meet again. We know that it meets at x equals 1. So what that implies is that if I was to try and solve this, it shouldn't work. So what I'm going to do is I'm going to write this here, x minus 1, x squared minus 2x plus 16 is equal to 0. We already know that there's a solution at x equals 1. We know that already. Because we know that we're trying to prove that it doesn't meet again, there shouldn't be any solutions here. So I've got a quadratic, x squared minus 2x plus 16. How do I determine the roots of a quadratic? The discriminant, right? Let's use the discriminant. Let's apply it and see what we get. So applying the discriminant, a is going to equal 1, b is going to equal minus 2, and c is going to equal 16. B squared minus 4ac is going to equal minus 2 all squared minus 4 lots of a and c. That is minus 2 all squared is a positive 4. 4 times 1 is 4. 4 16s are 64. So it's 4 minus 64, which is equal to minus 60. That is less than 0, right? What does that mean? B squared minus 4ac, the discriminant, is less than 0. We know what that means. It means that there are no real roots. No real roots. So all you got to say now is that, well, we've proven it, right? We've proven that there's only one solution at the factor x minus 1. So what we're going to say is that there are no real roots, and hence there is only one solution to, and then that bracket there, x minus 1, x squared minus 2x plus 16 is equal to 0. And so therefore, the normal to C at P, what did the question say again? Let's just get the question again. Prove that the normal to C at P does not meet C again. So all you're going to just do is say, now therefore, the normal to C at P does not meet C again. Again. And then you could put in a bracket just to really bring it home. Only meets at the point P. At point P. Right? Done. P was 1, 0, wasn't it? Just to make sure. Yeah, it was. That is it. There's no way an examiner could read that. Examiner will look at that and be like, Fez, you got your full marks. Well done. Yeah? Make sure you just make it very, very clear to the examiner that you know exactly what you're doing. And yeah, that is the paper finished. Wow. Friday evening, I'm about to play some football. See you later. Hey guys, hope you guys are doing well. So yeah, that's the end of the paper. 15 questions done. It's such a big weight off my shoulders when I get a walkthrough finish because they take such a long time because you just got to do the questions and you got to film it. Sometimes you don't get it right. But yeah, happy that it's done. And I'm hoping, most importantly, that you guys have found it helpful and any questions that you found maybe a bit tricky, you've understood now. I'm actually trying to make a plan. So after this, I've got paper 3 to do, and then that will be all of 2024 done for the A-level papers, A-level and AS. I'm trying to make a plan. I think I'm going to work backwards because I've done 2024 now, or once I do the stats paper, and then 2023 I've already done, and I'm going to try and do the rest of the year. So 2022, 2021, 2020, 2019, 18, and the sample assessment papers as well. And then that way I'll have all of the walkthroughs done on my channel. So hopefully I can get that done by the end of next year, you know. I think that should be feasible. But yeah, again, hopefully you found this helpful. Anyone that's always looking for any extra help or support, I do offer group classes online. Just go to my website, MathsWithDan /courses, and you'll find it there. I'll put all of the details in the description as well for anybody that's interested in some weekly support. But yeah, I hope you guys find it helpful. Again, as I said before, it's always appreciated if you like, comment, subscribe, share with your friends, share with anyone that you think will find this helpful. Let's get to 10K by the end of the year. Come on, guys, we got this. But yeah, again, thanks for all your support, and I'll see you guys soon. Take care. Bye bye.